Continuing down.
So here we are, we have the seafloor coming into sight. It is 15:37 UTC. I should have checked earlier. Paul, can you remind me what the first marker number is going to be today, please?
1 second, please.
Thank you. Or anybody sure if you have that information available?
I think it should be 106, but I wasn't quite sure if we actually did a last marker yesterday.
Okay. Let's see. Jameson's normally quite a guru on this kind of stuff as well, so let's see what he has, or we can just see how far back I can scroll through the event log. Go ahead, Nav. That sounds good. That was what our records show, was marker 106 would be the first marker. Okay, so marker 106 is going in now, and that is the start of today's dive. So our depth here is 3501 meters. The heading of the vehicle right now is 204. So we're looking a little south and west. And we are sitting on biogenic carbonate. I think that sums up the feelings of all of us. Thank you for that contribution. Well, Bobby, if you're asking who that was, it clearly wasn't you, and I promise you it wasn't me. Maybe it was the seafloor. Okay. Oh no, it's that yellow ROV again. Not the same ROV we see every day down here. What science wants to do is get off this mud. Nav, this is watch lead. Yeah, I think what I'd actually like to do is go due north from here, up this first contour, and then if you could put your contour, do you have your cursor you can drive by? So I think if we went due north up across that first contour, that's good, and then we'll aim for the topographic high northeast from there on our way to 2, if that's okay. Yeah, so let's go to this point to the north first. If anything today, we're going to want to err on the west side of the peaks, but we'll see what the guys from the beach drive us to. But let's just go due north first of all, and that'll get us on the happy side of the hill. Conversely, if you think about how much of the ocean floor is covered in sediment compared to how much has black smokers on it, then you need a lot more sediment in your lives before you've made quota. Your eyes have been artificially biased towards hydrothermal activity so far this week, I'm afraid. And what's that little organism we're looking at there? Gonna take a little quick look, pilot. We're at a depth here of 3503 meters, heading 114. And that looks like one of those little dandelion things, is that correct?
Not sure, just holding judgment here at the moment.
Okay, let's wait till we zoom in and then we can see what it is we think we see.
Be a sponge.
And while we're looking at this guy, we're just, so you know, we're just uh, taking the time here while the ship is setting up.
Now that's really interesting. That's a stalk sponge related to one called Hylanema. And what you can see going down from the sponge are sponge spicules. The sponge, the filtering part is the piece at the top, and then the dark brown stuff going down is a sponge spicules, and it looks as though it has something growing on it. There's some papers on the fauna of sponge stalks. I think that's what it is.
And are those anemones growing on the side of the stalk?
They look like it to me, but I'm not entirely sure. A nice little community.
Mm. And what's interesting there is that it's not like this is any rocky substrate. Elsewhere where we've been driving across sediment, we found rocky environments, and then there's all kinds of interesting animals taking advantage of the firm foothold. And this stalked sponge is just growing out of the same kind of sediment we see most places.
Do you know what I think these might be?
Go ahead.
I think these might be Stauromedusae. These are scyphozoans that actually attach to the seabed. They don't come under Scyphozoa anymore, they come under Stauromedusae. And I'm just wondering if they're Stauromedusae attached to the seabed.
So do you want us to pan down to where it comes out of the ground? And see how it's
Sorry, I
attached?
mean attached to the stem of the sponge.
Oh, I see.
Can you see?
it? Yes.
Because if you take the stem away, they look like medusae, and so they might just be Stauromedusae.
Hmm.
Very, very rare.
Well, that's not a bad start for the day then, huh?
Assuming that's what they are.
Well, I like the story, Paul.
Oh, I'll make up a couple more of it, I expect, by the end of the day.
Another hour, another discovery. But they're very pretty as well. So there's one down on the bottom left. Should we have a look at that? Because that seems to be just sitting in the sediment at the bottom of the stalk.
Chris, can we get the ROV temperature right now near the bottom? Is it like
Yeah,
2.5 or something?
It's 4.25, which is,
Oh, it's hot.
well, actually not that remarkable for around here.
Even though we're 1,000 meters deeper?
You know, I can have a look at that.
Submit that looks more anemone-like than the ones further up. But very nice anyway.
I think you have to go, remember, Bobby, that really deep round here is actually 5,000 meters, so just an extra 1,000 meters, and there's still another 1,500 to go.
Actually, Chris, I think we have two. I think we have the anemone down at the base, and I think we have Stauromedusae on the stem. The colours look different, and the morphology looks different.
Two different things.
We mustn't forget the sponge parked at the top either. Stace Bewley published some papers on this 3 or 4 years ago.
Very good.
Chris, I didn't mean hot. I meant perhaps slightly elevated above ambient temperature.
Possibly, yes. I would need to, if anybody's listening can bring me my external hard drive that has all my other data on it and brings it into the control room, I could actually check that. I don't have the data on my laptop in front of me right now.
That's okay, but maybe we should try and keep track of temperature as we go along today.
Yes, good idea. And my noble elves are busy scurrying around Santa's workshop right now trying to generate that data set for me, or I'll get my hard drive and bring it to the lab. Nav,
You've got
watch lead.
elves too?
Yep. Are we, how are we doing with the guys setting up? Pilot, is it possible to get a zoom as we fly to look at the sediment grain size? let's test that. You have a look at that, Paul, and tell people what you see. I'm just busy pulling up the temperature data from past cruises in this area.
Harvey Nav Bridge.
Go ahead, Bridge. Are we going part way here, Brian?
Can you zoom out on the high pack a little bit?
Steve thought
Show
it
us,
might in fact
what
be
our
coarser. There seems to be a fair amount of fecal
Yeah, we
matter
don't have
here as
a
well.
waypoint set up for this. We're just going to go 100 meters due north to get on kind of the northwest side of this hill.
Okay.
And then we're going to
Yeah,
shoot
I'm not
north.
really sure, Chris.
Okay, so no list of waypoints like yesterday.
Little interesting little holes
there
in
are
the sediment.
waypoints, but the
There's
first one
certainly
is
an
going to be
infauna.
northeast of the peak of this hill.
Okay, thank you.
You're welcome.
And for those of you who asked earlier, I'm just looking up. The nearest CTD station I've done to this point is admittedly about 20 miles away, but that was a station that collected water down to 4,500 meters, and the temperature at 3,500 meters was 4.25 degrees Celsius. Temperature right now is 4.2491. It should actually get a little
hot
cooler.
dog.
In terms of raw temperature, remember, this is not potential temperature. So as we come up to 3,400 meters today, we shouldn't expect too much change. Should be between 4.25 and 4.23 all day. So any departure from that. So what we're looking for, anything above 4.25, we could do that by going deeper, but we really shouldn't because we've got an ROV that doesn't want to go much deeper. Certainly if we get past 4.3, we shouldn't see that unless we dive past 3,900 meters. So 4.25 is our baseline, and anything warmer than that is worth getting excited about. Somewhere in this vicinity, there was actually once a dive by Trieste, the same submersible that went all the way to the bottom of the Marianas Trench. Of course, the trouble with that is it can go straight down and back up again. That's quite coarse material. Pilot, can we zoom on that chaff that's down the bottom right of the screen there? Just this coarse stuff in the bottom. I just want to see. It looks quite gravelly compared to the rest of the sediment we've been looking at. I want to make sure it's not shell chaff or something. There's actually a really nice curly shell in the top left of the corner of the screen right now, Paul. Can you see that?
Got it.
It's like the kind of thing children would find at the beach. So is that something that will have come all the way from the surface, Paul, or is that a benthic organism's remains?
I think something is either from the surface or benthic organisms remains.
That's
What's in the screen now is fecal matter.
is that holothurian poop?
Certainly looks like it.
Lovely.
There's lots of little brown chunks in there too, which may be pieces of rock.
Yeah, that looks just like we were seeing yesterday. This sort of black and brown spherical things. I mean, heavily weathered. I mean, maybe it's basalt fragment or something. We don't think it's an animal. We think it's a mineral.
And we don't think it's vegetable either.
No, we're pretty sure it's not vegetable. Okay, thank you, pilot. That's useful to actually have that that quick glimpse there. So it's coarse material like we've seen elsewhere, but it looks like it's more of the same kind of coarse material. What's that
Bridge.
dark thing? Can we fly over that?
Bridge.
Yeah, 50 meters to go, 50.
Thank you.
Can we have a quick look at that dark thing as well, pilot? Do we have time, or is it time to move on? A piece of wood, maybe.
Snap zoom, possibly.
Yep, just happening. Yep, we see wood. Anybody want a marker there? Why not? They cost nothing. Nav, could we drop a marker here, please, for this woodfall? I believe that should be MCR 107.
Looks like bamboo.
Okay, moving on, I'm afraid. The ship's moving, everything else is happening. Paul, when we've seen woodfall before, it was up at about 2,500 meters. Somewhere in this vicinity, there was actually once a dive by Trieste, the same submersible that went all the way to the bottom of the Marianas Trench. Of course, the trouble with that is it can go straight down and back up again. That's quite coarse material. Pilot, can we zoom on that chaff that's down the bottom right of the screen there? Just this coarse stuff in the bottom. I just want to see. It looks quite gravelly compared to the rest of the sediment we've been looking at. I want to make sure it's not shell chaff or something. There's actually a really nice curly shell in the top left of the corner of the screen right now, Paul. Can you see that?
Got it.
It's like the kind of thing children would find at the beach. So is that something that will have come all the way from the surface, Paul, or is that a benthic organism's remains?
I think something is either from the surface or benthic organisms remains.
That's
What's in the screen now is fecal matter.
is that holothurian poop?
Only looks like it.
Lovely.
There's lots of little brown chunks in there too, which may be pieces of rock.
Yeah, that looks just like we were seeing yesterday. This sort of black and brown spherical things. I mean, heavily weathered. I mean, maybe it's basalt fragment or something. We don't think it's an animal. We think it's a mineral.
We don't think it's vegetable either.
No, we're pretty sure it's not vegetable. Okay, thank you, pilot. That's useful to actually have that that quick glimpse there. So it's coarse material like we've seen elsewhere, but it looks like it's more of the same kind of coarse material. What's that
Bridge.
dark thing? Can we fly over that?
Bridge?
Yeah, 50 meters to go. 50.
Thank you.
Can we have a quick look at that dark thing as well, pilot? Do we have time, or is it time to move on? A piece of wood, maybe.
Snap zoom, possibly.
Yep, just happening. Yep. We see wood. Anybody want a marker there? Why not? They cost nothing. Nav, could we drop a marker here, please, for this woodfall? I believe that should be MCR 107.
Looks like bamboo.
Okay, moving on, I'm afraid. The ship's moving, everything else is happening.
Experimental wood's been put out at every depth from 100 meters down to 5,000 meters and it's all been colonized by Xylophaga. Different species, very, very diverse genus. And that's one of the things that makes it very interesting. It's a bit like whale falls. The species diversity within the genus Osedax on whale falls is very wide, and it seems to be the same with Xylophaga. And again, it's something to do with these quasi-ephemeral environments on the deep sea floor. And the clever thing is, how does the larvae of either Osedax or of Xylophaga find another piece of wood or another whale fall?
So it's not that dissimilar from our conversations about, how does a vent site get colonized if it springs up, and how do the animals know to find that? It's the same kind of thing of these little oases on the seafloor, and how do organisms get from one to the next?
Exactly the same intellectual challenge.
Are we passing through A01B? Okay, well, let's drop a marker when we actually pass through there, please. And if you could let me know when you do that. Thank you.
And can you let us know as well, please, Chris?
Will do, Paul. Good. That's great. Yep, thank you. So we are now dropping marker MCR107. Let me just check that. Nope, sorry, MCR108.
I think that's 8.
Yep, now can you confirm that's MCR108, please? Thank you very much. So, but just hanging out a little bit off to the left, which gives us a chance with our sonar to actually see if there's going to be any bright returns. Yesterday when we were approaching a cliff face, we could actually see the boulders coming down from the hill slope, which told us when there was bare rock available to look at upslope. So in the same idea today, we can hang out just to the left, just to the west of the summit, in the hope that that will also give us a clue of whether there's going to be any fresh rock to look at.
Looks like a Serianthid.
Yeah, do you want a quick snap zoom of that? Chance to do a quick zoom on that, pilot? Not so easy to do at 0.3 knots. And we're viewing this at a depth of 3475 meters, heading of 135 degrees. Would you like a marker here, Paul?
No, I don't think so.
Okay. It's been noted. We know we've seen it.
Poor thing's most likely never been so disturbed in its life.
Any idea how long those things do live, Paul?
Absolutely none.
Right. Okay, thank you very much, pilot. We are ready to move on. meters across the seafloor are the longest.
Arobina Bridge.
Go ahead, Bridge.
Yes, 50 meters to go. 50 meters.
Thank you.
Here we have some rocks. Nav, how are we doing in terms of ship position? Are we going to go get taken past here? Okay,
Does that look like a rounded
let's
pillow just sitting there?
just a moment.
"109, Chris."
So we are at a depth of 3471 meters. We're facing on a heading of 088. So we're facing due east into the hillside. And this is the area where we'd seen bright reflectors previously. We're just checking out this rock types right here. And I should be online. If the guys in OSEC can confirm, can you still hear me?
Yeah, we can hear you now. Doesn't that look like the sort of a pillow sitting right there,
Yeah,
right
I think,
by the lasers?
yep, I think I can see radial fracture just between the two laser dots, or just south of those.
As a non-geologist, I
Right.
agree.
Let's zoom in on there at the moment. And
This honestly looks like the freshest stuff we've seen to date.
yep, agreed. Paul, as a non-geologist, what did you want to say? Sorry.
Said I agree.
Oh, right. I thought you were going to tell me something about the little animals that are living on the rock just there. Pilot, I think we want to zoom down a little bit, please. Sorry, pan down. It was the bottom piece of that rock, maybe zoom wide. And we would like to spin the vehicle so it's looking to the right. It's the stuff under the left laser, I think, was the pattern we were interested in. That's because that's looking at the outside. I want to look at the inside of the rock. Sorry, I did, didn't I? Sorry. The other right. I think the face we're looking at there, that would be the outer surface of that pillow. And it's almost like a fan shape. This is what we were trying to...
Chris, is there an edge off there to the left?
It could well be. That's beautiful. Can we zoom in on that, please? But keep the whole... But don't zoom too much because we want the whole boulder in the field of view. Oh, I can see two navigators. There we go. Now I can see the screen again. Great. That's pretty nice, Bobby, huh?
We're liking it. We're liking it.
I think that's kind of unambiguous basalt.
I'd say this is the most unambiguous basalt we've seen the whole expedition.
Yep. Very good.
Have we put a marker here?
We have, Bobby. It was marker 109.
Thank you.
Have you seen enough of this particular piece of rock, Bobby, and we can have the pilot move off?
Yes, please. If we can sort of move back a bit and get an overview of this
Yep. Remember
group of rocks.
the ship only just stopped moving, and Sirius is still moving, so we may have to wait to let things settle out. What the co-pilots told me is this is the first of a whole series of ridges along the direction that Sirius is going to swing. So I'm going to just let things settle out and see where we end up. But we have a marker here. If this is the best thing we can see, we can come back. But we suspect there may be a whole bunch of other stuff that's coming up that we better look at in as much detail, and they may actually be better ridges according to the sonar. So
Cool.
let's go ahead, Bobby.
Excellent.
Okay. I'll tell you one thing I spotted there looking at those in close-up is I wasn't in the other sites we've been to. I've been impressed by what
Yes,
looked like the
go ahead.
darkest stuff when we actually
That's a
zoomed in
small
is always
ship,
covered with manganese
10
oxide
meters.
coating.
Bearing 270
And
at 0.2
my
knots.
first impressions for those systems was that the darkest rock faces we saw there were
Right.
actually rock faces not covered in manganese oxide,
10 meters.
which would again be
270
consistent with this
degrees at
being
0.2 knots.
relatively fresh material.
Yes, thank you.
Alright, starting now.
Yeah, I agree. I think that was really an interesting observation.
And Nav, this is watch lead. I think the co-pilot's idea to move off to the west is going to be a good strategy for the whole day, actually. This is, I think, coming along the west side of these topographic highs is going to be better than driving along the top. Exactly, then we can stand off to the west with Sirius, and then Little Herc can come into the east. I think if we set up like that, that'll be a good configuration for the rest of the dive. Yeah, so let's we'll let the ship finish moving, let ourselves settle up, and then just move position accordingly. It's worth taking the time to set this up right, and then we can, you know, it'll be a good investment for the rest of the day. Thank you.
There's wet paint on the ladder. Really?
Arabina Bridge.
Go ahead, Bridge.
Yes, we finish our move.
Thank you.
Alright.
So we currently have a system, as you can see, that Sirius can see Little Herc directly ahead of it, but Sirius is actually facing a little bit south of due west. So it's actually facing downhill and back behind the way we came. So that's why we want to set things up, because that means Little Herc is then there's basically a sloping steep ridge or hill slope downhill behind us. So what we're going to be doing is setting things up. Now the ship has stopped, we'll let things settle out, but the idea is going to be to bring Sirius out off the side of the hill, so that then Little Herc can use its tether to then fly in towards the hill from open water, rather than trying to do it down a sloping hillside. Little Herc at the moment is facing pretty much due south on a bearing of 180 degrees, back the way we've come. It's at a depth of 3, 4, 6, 7 meters, so we're already a little bit further north than the first set of rocks we came to. Our first observations there were that they were relatively fresh basalt, certainly the freshest we've seen on this trip. Anywhere fresher than the basalts we've been looking at the previous 2 dives on the top of Mount Dent. We saw an absence of manganese oxide coating as one of the reasons for us believing that these are fresher. And I think that's most of what I have to say right now. Pilot, is there any way we can spin through 180 degrees and see what's coming towards us? Or is that not an easy thing to do in terms of vehicle safety right now? Okay. So those are the rocks we've already seen. And then if we spin round facing out through west, we spin round to the north, and we can see there's plenty more of the same coming. So although marker 109 was dropped where we first saw the basaltic rocks, I think we've seen enough of those. There's no need to actually go back and look at them. We'll let the ship settle out, and then when everything's all good, we will come in again to the cliff face wherever we happen to be by that point. I suspect if we look at the navigation, the ship is currently up near A01C, which is the point we were making towards, and that's probably where we'll be doing our observations, immediately downhill from the highest point on the ridge. In fact, the stern of the ship right now is right over the shallowest point on this ridge.
There have been some nice bits of pillow that we've seen. Beautiful pillow.
And pilot,
cracked
can we zoom on
pillow.
that little white creature that's just to the left of your lasers now? Looks like a squat lobster as far as I know, but let's see what the biologists put in the event log. They like it as a squat lobster too. Absolutely. As opposed to the engineer and geologist definition of squishy stuff. Even the crustaceans are squishy stuff by engineers, right? He's a 10 centimeter long squat lobster. So, squat lobsters, people, do they just occur everywhere? Is it a typical benthic organism that we should expect anywhere, or I think this is the second one I've seen since we came to this waypoint.
There are 690 known species of squat lobsters.
And they can occur out on the abyssal plains, or do they like rocky terrain?
Just about everywhere.
There you go. Ubiquitous.
And all over the place.
As well. Ubiquitous meteorologist. Again, very clear radial fractures in the fresh rock surfaces that we could see just there as well. Just so you know, following at home, the pilot, co-pilot and navigator are still setting up just how to set this up. You can see at the moment we are facing due north with Little Herc. Sirius is still looking out to the west, so Sirius is still uphill to the east of us. And so that's what we're going to do is put in a further ship move so we can bring the ship over some tens of meters to the west, and that will allow us to actually get down and look at those rocks in more detail. You can see there's some really interesting rocks downhill from here. So that's basically where we want to be. We want to be further west and further downhill. And then we'll be able to face into those rocks and look at them in some detail.
So for those who've been following the mud dives for the last few days, the geologists are fairly excited right now because these are good-looking basalts and very recognizable,
Hey, could
and
we have a
in
ship
fact
move
potentially
40
fresher than
meters,
anything we've
bearing
seen so far.
270
So this
at
is an
0.2
exciting result
knots.
already, and we're only less than an hour into the dive.
Exactly, and I think we've also
40 meters.
something I've learned as well that I should have thought of before
Thank you.
picking the final waypoints last night. I'd picked them along the top of the hill, but of course when we were diving on the volcanic ridges at the very shallowest point on the actual volcanic, or up on the top of Mount Dent, what we actually found was along each individual ridge that the tops are so smooth they can accumulate the sediment. It really is off to either side is the place to be if we actually want to see the rocky outcrop. So I think that's what we're going to do is basically revise the plan, the final plan I'd put in today. We can see now exactly why it is that the backscatter is brightest on the sides of the ridge and not on the top. It's because it's on the sides is actually where the slopes are so steep that the sediment doesn't accumulate and the rocks are exposed so beautifully as they are now. So we
And they are beautiful.
aren't they just?
Now we just need the red glow.
Well, but they're only pillow basalts, remember? We haven't seen the magic word yet. But we're only
Smoking sheets.
we're less than an hour in. But you can see just above the laser to the right now is a cracked open pillow basalt with radial fractures. So the left laser, that surface curving round from top from 12 o'clock to 9 o'clock would be the curved outer surface of that pillow. Off to the left of the lasers and just down below in the bottom right hand corner you see a beautiful smooth outer surface, and in fact directly under the lasers now, that beautiful rounded surface that's diagnostic of pillow basalts. May even be a lava tube there. You can see a cracked open underside below the lasers, but immediately left of the lasers this perfectly smooth, the sediment just runs onto it, but that's actually the rock to the left of the left laser now. That's how these things get their names of pillow basalts. Beautiful and smooth on the outside.
Crunchy on the inside.
Well, actually, you know, when they form, of course, they're more like a hard-boiled sweet, right? They chill on the outside first, and then they have this gooey, liquid, soft center. Of course, if you bit into it, you'd get 1200-degree lava, and that would burn your tongue. You'd also have to have extremely large jaws to break into something the size of a pillow lava. But that's kind of, you know, in a little nutshell, that's kind of the secret to hydrothermal activity as well. Just because things can freeze solid as a lava doesn't mean they're not still hot. The eruption temperature of these things are around, is it something like 1100 degrees Celsius or so, Bobby?
Yeah, that's true.
And and if the ambient temperature is only 4 degrees Celsius, then they can cool down real fast. And for those of you paying attention to temperature ranges, the temperature here is 4.252 degrees Celsius. So we haven't got our magic above 4.3. Nothing to get too excited about from the temperature yet, but that's fine. The rocks are really nice here, and we really like what we're seeing. It's in terms of one of the hypotheses for today, we really wanted to say we could find fresh volcanic rocks at this depth, at this location, and that's what we found, the freshest volcanic rocks we've seen yet.
So, Chris, can I ask, have we disturbed the sediment, or is there just an awful lot in the column sort of ambiently?
I am pretty sure that's actually our own thruster wash as we've been moving around here, but I would just confirm that. Pilot, these particles here, those are of our own making, is that true?
Yeah, my hypothesis for those is that I got some snow on top of the vehicle and I bagged up, it all came off in a cloud.
Okay, understood. Good hypothesis. But let's not test it by doing the same thing again if you don't have to.
Good hypothesis, but wrong.
No, it is. I mean, I think one of the other things as well when we're setting up like this, because things are still settling out, is that particle concentrations in the water column become more apparent as the vehicle lifts further off bottom as well. It's a longer light path between us and the seabed and back, and so that can also, that's another way we can actually get a false positive of suspended material.
Look at these pillow surfaces all over in the image right now.
It's just beautiful, isn't it? I mean, this is textbook stuff, only I've never seen it this clearly in a textbook.
This is like I feel like breaking out in song.
Don't let us stop you.
Don't worry, I won't.
Okay. Very good, pilot. Okay, Bobby, we have enough tether right now. If you want to pick a favorite rock in your field of view that you'd like us to look at, we can zoom in on any one of those. Choose carefully.
Just below the lasers to the right.
To the
So there's a big slab coming down that the lasers are just there, and then just down a tiny bit.
down? Down from there, please?
Yeah, the next boulder down.
That one under the lasers now. Is that the one, Bobby? I believe so.
If we could, yeah, right there. Zoom right now.
Yep, zoom on that, please, pilot. You realize that's the one that's got the biology on it, Bobby?
Well, that's good. Everybody gets something. Okay, now we're looking for shiny glass.
Oh, you really are greedy, aren't you? And shimmering water as well, probably.
Yeah,
Okay.
but...
So, okay, that's it. So, pilot, so you know what we're going to be looking for next when we look at these things. When they first erupt, the outer smooth surfaces, the bits that I've been asking you not to look at earlier today, that's what we want to focus on next, because when these things first erupt, they quench so quickly on the outside that the mineral structure is basically frozen in a homogeneous mass. So it's called glass, and it actually reflects light really beautifully. So if you'd like to zoom in further on this surface, please, when we get the chance.
You notice the radial fractures towards the squat lobster.
Yep. And so this is looking on the outer side of the pillow surface. We have our 10 centimeter lasers just in the field of view there. Okay, no glass on this one, I'm afraid,
If we
Bobby.
could go down about 5 centimeters.
Copy, Rich.
Would you like to go down 5 centimeters? Very good.
That's correct.
And look just there, please.
Right there.
And do we have any further zoom available for that dark patch just at the bottom? It's good and dark, but I see no glass, I'm afraid. Okay, is that good, Bobby? You happy with that?
Yeah.
Okay, thank you, pilot.
So do we want to look at the lobster or not?
Oh yeah, why not? Bobby's graciously asked if we want to look at the squat lobster as well, since we're there. And she sounds generous, but I know what she really wants is a really good still of the radial fractures that the squat lobster's sitting on.
Don't give it away.
Shh! Yeah, they might be listening.
Lots of pillows.
But I don't think that was the one we wanted to look at. There's one on this rock here. Wasn't that right? Wasn't there one on the one we were looking at? Ooh, there's one. There he is. The one
Yes, there
underneath
was.
the radial fractures.
Yep, that's beautiful.
And I think, pilot, if we could swing out so we could actually be looking at it, you'd be 90 degrees to your left when you're ready? Yeah. That's all right. The lobster's busy moving up towards the radial fractures to make sure the shot's really good. And you know that's an entire pillow that's cracked through. It's just above your lasers now, I think, pilot? You still see the same one? Yep. Right where there comes the landslide.
Uh-oh.
Oh, let's go look at this squat lobster while we're waiting. And see if the dust clears from the other one while we're doing that. Is that a viable thing, or do you want to... And the dust may settle, if we're lucky.
We can go if we need to.
You guys are lined up nicely now. I think our next tour will be
These are very good pillows.
And I'm pretty sure we've moved compared to where we first saw the rocks, so I'm just going to check that with Nav.
So if we want to move from this side, it's not a problem at all along the slope and head up because there's probably a lot more to see.
I believe that should be MCR 110.
Agreed.
That's biology. Okay. Thank you, Nav. Thank you, Nav. That's MCR 110. So, team, we have the ship set up, seriously set up off to the west of the ridge. We're in a position where we could proceed along the ridge. I think we've, I get the impression from Bobby too that we've seen enough to know that these are good fresh pillow basalts. We're happy with what we've seen, but we're ready to start moving along strike again. Is that correct?
Absolutely. Keep going.
Okay. Let's start up 0.1 of a knot, I believe, rather than the normal survey speed, just to see. I think our co-pilot said there's probably about 40 meters of this stuff to see, and then if we get back into sediment after that, we can then start cranking the speed back up again. So, Nav, this is watch lead. If everything's in a stable configuration, I think what we'd like to do is start heading on a generally north bearing so that we can actually keep Little Herc working on this rock face as it proceeds up, which looks like from the contours it's kind of due north from here for a while.
Yeah, the contours say it's due north for about 40 meters, and then it starts bending to the northeast.
Okay, so let's head. Let's make that first move 40 meters at 0.1 of a knot, and then if the rocks run out, we get back into sediment, we can bring the speed up again.
Alright, I'll call it in.
Thank you very much.
Let's see,
Copy enough.
Go ahead.
Hey, could I call in a ship move 40 meters, heading north at 0.1 knots?
Okay, 40
And so
meters.
everybody
due
knows
north,
the time here is
000,
16:51 UTC,
0.1
11:51 aboard
That's
ship.
correct. Thank you.
Starting now.
We are at a depth of 3466 meters, and Little Herc is pointing almost due north, heading of 359 degrees now. So passing north over significant fields of pillow basalts, pretty abundant squat lobsters. There's 2 in the field of view right now. Seems like there's one every 5 meters or so as we head over this rock type. So quite high concentrations of squat lobsters. Not much else here. It's basically squat lobsters or basalt. Those are the specials of today. We're doing a very short menu for Saturday lunchtime today. So what we can do now is just, as we're going due north, Little Herc is looking a little east of north. So what we're going to be able to do is probably swing out from the hillside and maybe even drop down and look at some more stuff. Or we can just keep going as we are. We'll happily accept requests from the beach.
None yet.
Zoom left. I think I heard a request to zoom left from the beach, but I wasn't sure. Can you repeat, please, Osek?
No, we just want to continue on.
Okay, very good. Yep, so we're happy actually just to keep moving, pilot. The again, we can see very clear evidence in this field of view of pillow basalts with radial fractures. It's a nice tube just below the lasers there. You can see the curvature around from left to right. and then the fractured open end of the pillow basalt with the radial fractures exposed, just coming under the lasers now, just below the lasers. And those of you watching back ashore, and Bobby in particular, it's not obvious that these are in situ at the moment, but well, I can't really tell either way, can you? I suppose there's so much sediment
Yeah,
cover,
some
it's
of them.
impossible.
No, Chris, some of them are definitely in situ, and they look like they have been flowing down the slope from some sort of vent that's further up the slope. At least the ones in the last at MCR 110.
Right. And I think some of those ones I just saw just now, that's what I was wondering, is you see tubes that are broken open on the downhill side. That's quite a flat slab
Yeah,
on the right.
that's
Pilot,
correct.
can we spin right there, Pilot? Oh, no, I think that's probably just the sediment that's flat, isn't it? That's buried over the top of the lava. Can we zoom on that,
Right.
just there? That dark face? That hasn't got the round blobs of a pillow lava, has it?
I think that surface with the sediment on it is actually is the actual outside of the pillow.
You think that's the top of the pillow and then it's flowing downhill left to right?
Yes.
Okay. All right, thank you, Pilot.
So Chris, so back to your question, I honestly think this stuff is in situ, and it really has come down from some sort of vent nearby. These are really quite large pillows. Some of them are up to 2 meters in diameter at least.
Which is getting up to the high end, right?
I'm not much of a pillow basalt person, but that seems thick.
Seems bigger than I've seen in field trips I've been taken on to see them in situ on land.
Same with me, but I don't have that much experience.
Well, we didn't come here thinking we were going to be looking at pillow basalts on this cruise, right? We thought we were going to be up on the hilltops looking at the core complexes.
This is a core complex. It's just been the axe murderer
there
came.
You go. There you go. So maybe this should become the Able, not the Hudson core complex. We already have a Kane fracture zone, right?
Yeah, we do.
Okay, so if we're seeing more of the same good stuff that we like, would you guys ashore be happy if we doubled the speed that we pass over these and bring it up to 0.2 knots?
Yes, that's fine.
Given that we're in
because
reconnaissance mode.
Right, as much ground as we can cover today is a good thing.
And I think we're well calibrated now. We know what pillow basalts look like from a distance, that we don't need to look at them all in the same level of detail in the future.
That's correct. And I mean, to me, this is really interesting compared to what we've seen in the last 2 days, which was a lot of very angular, small bits of pillow lavas. These are far more intact compared to what we've seen.
And a further observation is that every time we saw any bare pillow faces for the last 2 days, they were covered in sponges. It was very hard to actually get to look at the rocks at all because they were covered in biota. Now, I know we're 1,000 meters deeper, but even so, you'd think something would have colonized them if they'd been hanging around for very long at all. So, Navigator, this is watch lead. Wait one, please. Pilot, could we zoom on those flat layers just to the right of your screen right now?
Smoke and sheets.
What do you see, Bobby?
Platy lava sitting on top of pillows.
And what's another way of saying platy lava?
Smoking sheets.
I suppose they probably ought to go further before we say we've really hit our magic word for the day.
Well, they've got to be red hot.
But those are, so that's 5 centimeter thick horizontal layers. So quite different morphology from what we'd seen before. This would actually speak to lava that's flown out horizontally over a flat surface, correct?
It can flow down a slope easily, but it has a different viscosity and so therefore has a different sort of character.
And doesn't it also speak to a rate of supply as well, that the pillow lavas, to get this kind of flow, you'd expect the rate of the eruption or flow of the lava to be that much faster?
Yeah, that's correct. So the morphology tells us something about the viscosity and the rate of supply of the magma to the surface where the eruption's being deposited.
Okay, Nav, can we drop a marker here, please? That should be
So this is
marker 111, I believe.
correct. This is what I was thinking we might have seen evidence of yesterday, whereas others were thinking that we might have been seeing fault surfaces. It's really difficult to tell in those older deposits, but it's absolutely clear here that these are probably sheet flows, if I say it.
Excellent. I'm very happy. Yeah, because we saw that kind of horizontal layering, but it was in amongst sediments as well yesterday, didn't we? Whereas here it was just clearly separate units, 5 to 10 centimeters thick, laying one on top of another. Okay, Nav, just before I saw that, what I was about to say is there was nothing new to see here and we were ready to move on, which shows how much I know, but we would like to increase our speed to 0.2 knots now, please. Yes, please. And although I didn't note it at the time when we were looking at those sheet flows, we did drop a marker there. Our current depth is 3468 meters, and then looking back into the hillside, we're basically looking due east. Current heading is 097.
Go ahead.
100 meters, 400, sorry, 040 degrees, 0.2 knots.
You want from our current position?
Sure,
Okay, so we still have 10 meters left in the other move.
doesn't really matter.
So 100 meters, 40 degrees, you said 0.2 knots? Or 0.1?
040 degrees, 0.2 knots.
0.2 knots. Okay, starting now.
Okay, it is 1701 UTC. It's just gone midday here aboard the ship on the Okeanos Explorer as we continue our exploration of the Mid-Cayman Rise. It is just gone 1 o'clock in the afternoon at the University of Rhode Island where our ECC is based. We are diving today at depths between 3,400 and 3,500 meters in the far southeast corner of the Mid-Cayman Rise. We arrived on the seafloor about 90 minutes ago on thick biogenic carbonate sediment. We drove up to the top of a ridge and have dropped down to the west side, and what that's revealed is that the ridge we're diving on is actually made up predominantly of basaltic material, primarily in the form of pillow basalts. We've seen evidence for the lavas having flown down the hillside from wherever they erupted, and in rare occasions we've also seen some evidence for sheet flows. We're now going to continue north. We're basically due west of one topographic high, where we've seen this freshest lava outcropping, and what we're going to do now is continue north past a saddle point and then onto another topographic high to see how that compares with what we've seen here.
So Chris, we're going to continue to move along this sort of wall towards waypoint 2, is that correct?
That's correct, Bobby. Yes, we're basically following the ship's going to basically head towards waypoint 2, and we're going to keep Sirius and Little Herc off to the west side, so we'll be downhill from the summit as we proceed. So Sirius right now is on a heading of 070 degrees, so it's tilting itself in a little bit, although the ship is heading on a more northerly bearing.
Okay, it looks like there could be some little bits of sheet flow in there. No, those are pillows, sorry. It seems more heavily sedimented here, so it may be that we've passed from one flow sort of to another flow that's slightly older.
Okay. And then, pilot, I think until we see anything remarkable, we're happy more to proceed. So if you do want to get yourself out ahead to see what's coming, that's fine by us as well.
Copy that. Thanks, Archie. We don't have too much tether to work with, so kind of bobbing along here.
Yep, understood. But this is nice. If we could just spin right, that looks like some more sheet flow in the top right corner there. Again, you can see those flat plates. Bit of an overhang there. The shadow picks that out quite nicely. That ledge sticking straight out towards us, just above your lasers to the right. We could
Yeah,
go
that's great. Thank
up
you.
a little and zoom maybe if you have time.
Sure. Bear with me to go for a little transition video.
You know, I don't know if you can drop down, but if you really could, what I've sometimes seen, but in dredge samples, I've never seen it in situ, is that these things have a flat top side, and if the lava drains away underneath, you get little drips hanging down from the underside of those flat sheets. It's like paint drying, that sometimes the lava can flow out. That would be an outrageous thing to be able to see in situ, but you guys have got the camera to try and do that.
Yeah, let me see if I can get up there.
Yeah.
Get your pilot some time, pilot.
I know I'm pushing my luck here, but I just can't resist myself.
Yeah, you can sit up for a moment.
I think since that edge is sticking out in an overhang like that, it's the one place we could get end onto that and zoom on. So it'll be the underside of that up topmost layer. Well, actually any of those platy layers right in front of you would probably be good.
Maybe zoom in to the side of the pit.
Yeah, let's try that.
Okay.
Okay, let's hold there. And maybe we come up a little bit. We're probably at geo-imagination. But can you see how the tops of those plates are incredibly flat and the underside are undulating? That's because when it first erupted, the top froze. And the way this could work is that the lava drained away underneath and left cavities where the water got cold. Or actually, it may have just held liquid lava, which then flowed away somewhere else. So you get these flat surfaces on the top and undulating on the underside.
So I think the camera can light up the bottom edge. Sure. Switch it on.
I've held rock like this in my hands after it's come up on a dredge haul, but I've never seen it in position on the seafloor. Maybe come a little bit, zoom a little wider. And I'm wondering if you really wanted to set this up, whether maybe the next layer down might be better just because you don't have the carbonate sediment in the way on the top. Some of the other layers had more bare rock, it looked like, on the flat upper surface. You might need to zoom wider for me to point you in the right direction.
You ready? Come on right here.
Yeah, that's probably just to the right of the lasers. There's a thinner dust setting. Yeah, that one just off the bottom of the screen there.
Yeah, the one's just below the lasers right now.
Your voice is a bit
Just another 2 centimeters. Right there.
Okay, that looks good. Yes. So that edge that's in the field of view there, in the middle of the field of view there.
Just zoom.
Yeah, we just have a little bit more time for trying to zoom this. The stills from this are going to be great.
We've already decided this is a highlight for us today.
The science highlights, Bobby? Sorry, you're very muffled today.
Sorry.
That's okay.
Yes, science highlights today with pillows right and left and a sheet flow in the topographic low between the pillows with these beautifully preserved sheet flows. And
That was
a squat
excellent,
lobster
pilot.
walking
Thank
by.
you very much. That was that's going to be a highlight for the day without any doubt as far as our science party is concerned. You know what? We didn't drop a marker there. If we're still in the same position, Nav, can we drop a marker there, please? And pilot, if you could just face back in so I can get the heading and depth, please. That's all right, I got it. So we're at a depth of 3469 meters, heading 110. Thank you, pilot. That was awesome.
This is marker 112.
I believe that's correct. I will just confirm. Nav, that was marker 112, correct? Thank you very much. Oh, you know, sure. Diva or Jameson, what can you see there? Paul's gone for lunch because he didn't. We had polykeet tube. Diva, can you tell us more?
She's thinking it's just a normal polykeet tube.
Okay, thank you. That was what I was hoping to hear since we just got dragged away. Although we did have a marker in the right place if we wanted to go back there.
So you were really hoping it wasn't a normal one, but
It's way too early in the day. I'm trying to keep Paul out the seat for an extra half an hour today so I get a little bit longer than he does rather than the other way around. But he... Bobby, the hint from the beach here is maybe you're a little close to the microphone, and that may be what's causing me difficult to hear you clearly today.
okay, I'm further back. Can you hear me better?
That is much better, yeah. If it was a little halfway between the two, would be absolutely perfect. You're quieter, but I can hear the words better.
Okay.
That's great. Just like that, it was perfect. It's a little difference. Apparently that was it. Somebody thought I was in a very quiet and subdued mood the other day, but it was just my microphone was 1 centimeter out from where it should be. Because nobody on the ship noticed I was quiet that day either.
We don't have headphones. We just have a microphone here
Right.
that we speak to at whatever distance.
Yep.
Big old pillow just went by.
More pillows. Great.
Back
But
online,
delay.
Chris.
Oh, hi, Paul. You missed a tube worm.
A real one?
Yeah, we didn't imagine it, but Diva said it was a polykeet, but
it was fake.
not chemosynthetic.
Did see some big pillows there, though.
You know, I had actually, when we came here before, the first cruise we had, was we sailed from Port Canaveral, and they had a giant dinosaur museum with a gift shop there, and I did have great temptation, but fortunately the gift shop was closed before I left port. I was actually going to go and see whether I couldn't find a trilobite in the museum, and then just put it down here somewhere for Cindy Van Dover to find one day. Okay, the engineers on the front have identified that as one of those guys.
Squishy.
Yep, one of those squishy guys. Okay, we have an advance on one of those guys from the beach front row. We've improved.
So all our biologists have agreed that on what the squishy thing is.
Yep, we see it is if I get the pronunciation right, a Cereanthid anemone.
That'll do.
Thank you, Paul. Let me tell you some more about the sheet flows. Oh no, sorry. Sheet flows are hot.
Bridge, I mean nav bridge.
If only.
Go ahead.
Yeah,
Well, they
18
were.
meters,
They have
3
been at some
minutes.
point.
Go ahead and add another 100, please.
100 at 040.
So we just want to
Affirmative.
find the toasty
And
ones
still
now.
0.2.
Affirmative.
Here's a question for the geologist. This might sound really dumb. Are we looking at the bit that's going to go eastwards, and then to our left Is that the bit that's going to go westwards?
I think we're looking at what you're looking at right now, Paul. Or if you went over the hill and up that direction, that's one tectonic plate, and behind us right now is the other tectonic plate.
Yeah, that was my question, yeah.
So as we head north, to your left is going to be the North American plate, and to your right is going to be some complicated bit of the African plate.
That's really cool.
Caribbean
Just seeing
plate.
that's the bits where, new plate is welded on.
And then where we're going to go on Monday, Paul, will then be a further plate boundary. If we go to the fracture zone, then that'll basically be another edge to that plate boundary.
So Paul, not a dumb question at all, a very excellent question, in fact.
You set us up beautifully to talk about plate tectonics.
Okay, come on, half an hour on plate tectonics then.
We're too busy enjoying the rocks.
So is the ship moving now at 0.2 knots?
That's correct, yep. And that's what you can see actually if you look at the view of Little Herc from Sirius. Sirius is actually catching up with Little Herc, so that's what the pilot's just going to do now, is pull away from the edge of the rocks and start zooming off ahead of us and get himself some a bit of a head start. Back over deeper sediment now. We're on a heading of 042 degrees with Little Herc at depth of 3475 meters. We're basically contouring northeast along the side of this hill. Where we are right now, there's more sediment uphill to our right, to the east, and then to the west downhill you can actually see a little bit more rock outcropping, more of the same stuff. Interesting that we must be between different areas where there are fresh volcanic vents uphill, I would guess. That we've had the time here for the sediment to accumulate, that it's that much smoother while still being at the same depth. Just going to step out a little to the left if we can with the ROV. And we see more pillow basalts down at the depth of now at 3477 meters. And you can see a nice view in the Sirius camera right now that the sediment rock edge is pretty much right in the middle of the field of view, directly along the line that Sirius is heading. Oh yeah, let's go look at those. We see some worms, the guys in the front row have noticed, around the rocks. So Paul, this may be the same things you missed earlier, but that's a much bigger cluster of them. Our water temperature, before anyone asks, is 4.24 degrees Celsius.
So it's getting colder.
Yep. Not significantly different, I guess, is the real answer. There's a nice one sticking out the bottom left as well, of the left of your lasers. There's one straight down there, if that's easy to look at. So I think, let's see, we're at a depth of 3478 meters on a heading of 105 degrees. Nav, could we drop a marker here, please? Very good, MCR 113. Now that may not even be the same thing we were looking at up before, so let's have a look at it and see what we get. we just do a snap zoom just to see what it is? Any ideas from the biologist what it is we can see there? Or is... There we go.
It looks like a little circular tube to me.
Okay, do you want to look at one of the others if we can? If we get time before we get pulled off?
Yep.
Okay, thank you, pilot. I wonder if we could just go up to the next rock up. How about that? Yep, let's just have a look at those, make sure it's the same stuff. The same things. Port identification so far is a serpulid worm, but there's probably 4 or 5 in that field of view, I think. So, yep, let's zoom there, please. How's that? Now that looks like a mud-covered tube worm to me, but what do I know?
No, I think it's a serpulid worm again.
Yep, more of
I
the
think
same
those
thing.
tubes are breaking down as well.
Yeah, it looks pretty old and dead, whatever it is.
I suspect they have a thin mucus coat
Okay.
lined with fine sediment.
All right, thank you, pilots. That was great. The biologists got to see what they wanted to see. So basically what I'm learning here, Paul, is there are many different kinds of worm that can have a tube that's about the same size and shape as the hydrothermal ones we were looking at up on the Von Dam site earlier.
Yeah, and to add confusion, some of those the tubes look like broken up gorgonians as well.
Yep. Many different ways for a geologist to get a false alarm.
That's right.
Nav, could we get a range to marker 2, please? Or A2?
Big sponge.
Very good. So here we go, and I think that might be the end of the rocks for a while. We're moving out over 100% sediment cover, so we're going to press on. We are on a heading of 080 with the little Herc, not spinning around, more like 020. And model point Sirius is pointing on 073. And little Herc's going to drive out ahead of us over this 100% sediment cover. And our water depth is 3487. Moving on, back on the lunar landscape. Nav, can I confirm we're still doing 0.2 knots with the ship? Very good, thank you. So we have about 200 meters to run to get to our next waypoint. That's where we're actually going to do close to a 90-degree bend in where we're going to head next. So for that reason, we're not going to make the ship go any faster just for the next 200 meters because it will take longer to slow back down again. So we're going to stick with our 0.2 knot survey, which is what we're used to. Passing over this almost 100% biogenic sediment cover. No evidence of any further rocks in our immediate future, according to our sonars. Which is kind of interesting, so that coincides with the fact that as we passed west of the absolute summit of the high of where we were heading for as our first target today, that's exactly where we saw the most rocks. We saw pillow lavas, we saw sheet flows, And now as we move further north along this ridge, we see increasing sediment. So it may well be at that point, by that definition, if it's the topographic highs are where the sources of the volcanism have been, then A02 may be quiet all the way to A02, and then as we head northwest from there up towards the next mound in a succession, then that may be where the rocks come again, is going to be after A02. I was going to say exactly the same thing, Pilot. From the bathymetry, we're expecting to approach a saddle as we get to the next waypoint. So moving on, it is 1729 UTC, 1229 aboard ship, and 129 in Rhode Island. This is Chris German in the watch leader's chair aboard the Okeanos Explorer. We are continuing our exploration of the Mid-Cayman Rise. We are currently headed east or north-northeast across the seabed on a volcanic ridge. The Little Herc vehicle is at a depth of 3,498 meters. We're passing over a ridge that's covered on the top with thick biogenic carbonate sediment, and the occasional little animal making a living down here. But what we've been learning all day today is that if you drop off to either side, what these ridges are actually made of underneath the sediment is relatively fresh pillow basalts and also some basaltic sheet flows. So although it doesn't look like much right now in the field of view as we spin around, this is actually a volcanic ridge. We're basically driving along right now, right where we are, is right on a plate boundary. To the west of us is one tectonic plate, to the east is another. The tectonics around here is pretty complicated in the Caribbean, but this is basically where two tectonic plates divide as we're heading along this line. And we were on a flat section of ridge just there. You can see now we're still on, let's see, Little Herc just now is spinning around to face due east, or we're looking to the northeast, and suddenly northeast is downhill. So you can see we've come past this, must be passing over this saddle point. For the last hour or so as we've been driving along, east meant we were facing into the hillside and looking at rocks. And you can see that in the navigation screen. Basically, we've come past that volcanic ridge with the pillow basalts and the sheet flow lavas. And we're now back over flat sediment. We're now back to heading along a heading of 350, so pretty much due north, and downhill is to the right and hence to the east. So we're a little bit east of the local high. I was wondering if we have the flexibility to drive uphill here to see how far we'd have to go to get to where it flattens out. Yeah, we seem to be on the east side of a hill and we were trying to get on the west side, so I was wondering whether that's just a local anomaly. But right now, uphill's to our left, right? So I was wondering within the length of our tether whether we have the option to actually get to the top of the hill where it flattens out. Oh, I wouldn't double back actually, Pilot, sorry. But while still, I would... Yeah, we don't want to go back the way we came, sorry. I was just thinking if there's a saddle point on where it's flat, and in fact we're there just now. We were facing, if you just spin a little to your left, please. Nope, that's good, thank you. That was the way I wanted to know was, so that's just downhill is straight the way we're all headed. And so, for those watching at home, sorry, I just a little disoriented there for a moment, but basically on a heading of 045, we're basically heading downhill across this saddle point straight towards the A02 marker. Yep, and that's on a heading of 057 right now, so that's the direction that's not sloping away to either side. That's basically straight along the saddle point, I guess. And our depth here is 3510 meters, so we've dropped back below 3500 meters. In fact, this is probably the deepest we've been today, I think. Nav, it looks like the ship's just about reaching A02, is that correct? So we'll give it about 15 minutes or so to settle out when they get there? Well, I tell you what, actually the ship can stay there because we're going to want to set it up a little to the west of A02 with the vehicles. We're probably going to do the same as before and follow up to the left of that white contour as we go northwest. So I think that sounds good.
Go ahead.
I'll stop, please.
I'll stop.
Yeah, Nav, if you have a moment, maybe we can zoom out on the HiPAC screen. Yeah, that looks exactly the line, thank you. Pilot, did I imagine that just got a bit murkier? I guess that could actually be a current blowing up over the saddle and down the other side. A Bernoulli principle. So everybody knows at home, if you're following on the navigation screen, the ship has arrived at the A02 waypoint. And what we're going to do, what we'd originally thought was we would actually march straight up along that long ridge to get to the high point. And in fact, what I've realized, and others knew it before me, is a smarter idea is what we're going to do, like we did at the last ridge, is that rather than go over the high point, which may well just be thick sediment all the way along the top, is we're going to go up the west side again of that saddle. As we pilot, do you have an idea which way that current's coming from? Sure, if we're just hanging out waiting for the ship and everything to settle up. Okay, maybe we can have a look down on the seafloor right just underneath you. There's some dark patch. I think maybe if you back up a little. Is that just coarse gravelly sediment like we've seen elsewhere? There's both dark and light coloration here. I haven't seen much of that lately. Okay. Nav, this is Watch Lead. Just to follow up on our last conversation, so what we would like to do is proceed up along that trajectory, probably kind of hugging probably the vehicle along the white contour and the one down from that. But we'd like to stop the ship when we get level with A03, because if we, as expected, we see rocks there, we might want to then go northeast up the hill straight towards A03. Okay, that sounds good.
Chris, you asked about the apparent increase in particle concentration. Did you get a response?
Sorry, we did. The pilot confirmed that he too thought he saw an increase in particle concentration. There's a thing in the event log that seemed to coincide with exactly where we're crossing this saddle point. We did wonder whether there was also an increase in current, but we did a drift test and there wasn't anything apparent there. But the water here is genuinely, we haven't stirred up the sediment, but there is a higher current here, so it may well be that there is flow coming up over the top of the saddle and basically the pass between the two mountain ridges. It's the wind whistling through the mountains. But it is our you know, we're not flying any higher than normal, so it is on a like for like basis. There does seem to be a little more suspended particulate material just here. And so what we're going to do now is we're going to head a little step north as we go past the our closest approach to the A02 waypoint. And then we're going to, which intriguingly was the one time where the top of the ridge coincided with the highest backscatter. And then we're going to start heading off. So a short leg due north is coming up, and then we'll start heading off to the northwest along the west side of the next big topographic high. Nav, did you put in that ship move request?
Sorry, sorry, Nav.
150 meters due north, 0.2 knots.
Thank you very much. And can we drop a marker here to coincide with that, please?
Thank you.
Thank you, Nav. So we're just dropping marker 114 at the saddle point. We're starting a new ship move of 150 meters due north at 0.2 knots. That'll get everything moving again, and then when we get through there, then we'll turn again to the northwest and start up towards the next ridge, see what kind of rocks we find there. Hopefully not rhyolite, that would confuse me.
Those would be called Icelandites.
And that's too easy.
Another bit of field work.
I can still spell that. It's when you get to the Trondhjemites that I get really confused. Way too many consonants.
Jacubarangites and all those really wonderful alkaline rocks from the East African Rift.
And presumably some of them are from Norway as well with the names they have.
Yeah, Trondhjemites from Trondheim, but the really alkaline stuff from continental rift settings have wonderful East African names.
Can we go there for our next exploration?
You're on.
There's a bunch of lakes there. We could even take the Little Herc team.
That would be so cool, actually. I mean, seriously.
It would. And they may even trust us after this cruise.
The water depths are far less, so the up-down time is much shorter. So we get more on the bottom time.
You're getting greedy again, Bobby. Just wait till we find you the shiny lavas on the next hillside. Okay, the time here is...
Then the shimmering water.
1746, stop it. 1746 UTC. We are at a water depth of 3511 meters. We are proceeding north across the floor of the Mid-Cayman Rise. We are on thick biogenic carbonate sediment. And we are heading to between two consecutive what we believe are volcanic ridges. We know the one to the south of us definitely is. The one to the north, nobody's been there yet, so we're about to find out.
Chris, as we motor over this sediment, can you please thank Mimi and the ship's crew for acquiring the beautiful bathymetry last night? It's a real blast to look at.
Oh, it is? Ah, I haven't looked at that myself yet, but so you guys are multitasking and having fun back in Rhode Island.
Well, you told us we needed to.
Absolutely. We need to know where we're going to dive tomorrow, so we need to start looking at that data. So that's really good to hear, and I will definitely pass the word along.
Really, really, really wild stuff, actually. The capabilities of the multi-beam system on the Okeanos Explorer really has helped us tremendously in terms of understanding more about the tectonics here in contrast to the existing database. So it's been truly wonderful that we've had the opportunity to continue to do the multi-beam program at night.
I think that is a very, very good point to make. We probably can't emphasize enough, can we, that although we're having a lot of fun and the video feed is the very immediate stuff that we can project over the internet for people following along at home with our exploration, but in fact it's a nested package here that in fact there are three separate teams all working in concert on the ship. There's the multi-beam team, the water column team doing the C2D operations, and the ROV, and it's the combination of the three that helps set us up each day that we can actually carry on doing more exploration. Even when the ROV's on deck, we're learning more about the seafloor and being able to pick targets. And that's allowing us to actually pose the questions of where's the smart place to go with the ROV the next day. When you think this, the dive we're doing today, we wouldn't have actually known where to come to or how to actually come and organize this dive if it wasn't for the maps that we made 36 hours ago. So it really is a great success of the whole concept that I've been really impressed with too, and I think in the same way you have. So, Paul, looks like we're looking at another one of these wood falls, and we think we can see little. Let's see if we can just set up and see whether we can't see some little beasties making a living out of this. Nav,
This does seem to have a bark on it as well, doesn't it?
Yep. Nav, can we have a marker here, please? Very good. Marker 115 is a woodfall with what look like little white worm-shaped things making a living on it.
Again, things seem to be using more as a substratum than a food source.
And then is this another one of those? Oh, nope. That looks distinctly anthropogenic. Is that from a pleasure cruise or something?
Mixer?
Let's. Can we have the lasers on, please, to see how big that is? Well, that's a big cocktail if it's 10 centimeters long. I don't know. Let's go back and look at the woodfall, can we, please? Maybe we can just zoom on what kind of animals might be living on the woodfall. So it's MCR 115 was the woodfall site. We are at a depth of 3505 meters.
So presumably this is a fairly recent cocktail mixer spoon thingy falling down, and there's a fair amount of sediment on it, which could be a useful bit of information.
Yeah. I was almost. Ah. Let's move on.
Oops.
I think we just ruined their Saturday. Is that another piece of woodfall directly ahead? Let's go look at that one. In the, but let's not. Yeah, let's not maintain the new. Let's not do the new traditional thing. It was the giant cocktail, wasn't it? The commentary put you off. Yeah. Looks like more garbage from the Carnival Cruise Lines. Oh, no. Bobby, that couldn't be basalt, could it? Is that just garbage? Yeah, it's floating around. That's not rock, that's garbage. But there's an
Looks like
anemone
rubbish to
making a
me.
living on the right of it. If you look to the right
Yeah, it
there,
looks like there's a
something's using the hard substrate to make a
ditches.
living. Just for a minute
Like
there, I
there's a
thought it
piece
could have
of
been the outer shell of a
string or
hollowed out.
thread.
Who knows? Okay, thank you, pilot. Nav, how are we doing with our ship move? Are we ready to start doing the northwest thing?
I think it's an old Wellington boot.
What sort of boot, Paul?
A Wellington boot.
I see, because we're still moving north.
Galoshes. Look to the left, I think you can see the foot.
Right, I know wellies very well. I worked in Scotland.
Need them there.
Okay, pilot. Let's just keep on moving. I've seen enough anthropogenic impact on the seafloor there, thank you.
Actually, it's quite remarkable how much we've seen.
Yeah, not remarkable in a good way though, Paul. But it seems more here than
Point
elsewhere.
taken.
But it's also amazing that, you know, it shows what the impact can be, the fact that had been colonized.
So now the real question is, how quick can a piece of fabric be colonized?
Well, we know we can do things like take woodblock experiments down, and we can take whalebone and things like that, and they seem to get colonized in a matter of months. So I guess we shouldn't be surprised that something in the history of pleasure cruises is assuming that's where these things come from. Of course, it's completely unattributable exactly where anything on the seafloor comes from. Humans have been sailing ships around for a while, and I don't think anybody's.
Wellington?
And it's not often people have thought the Caribbean's a better place to come to. Well, Wellington's probably been around, I don't know. If you see plastics, at least you know that that can't be any more recent, any older than the 1950s.
It might have been a lady's leather boot.
So the time now is just coming up to 1800 UTC. It's 1300 here aboard ship, 1400 on the at the ECC in the University of Rhode Island at the Institute for Exploration. We are proceeding across the seafloor in a generally northerly direction at a depth of 3502 meters on thick biogenic carbonate sediment. We're just finishing a traverse from one volcanic ridge to the next topographic high, which we believe is another volcanic ridge. And once we get there, we're then going to migrate up the west side of the second hill in the hopes that we will see fresh and interesting lavas just like we saw on the previous hill. Once we've moved, we have about another 70 meters to go. Once we get that far, then we'll be turning to the northwest up along the side of the next ridge crest. Yes, exactly so. Yeah, there is one obvious difference. What do we have here? A manganese nodule? Nope. It's
Looks like
Coconut,
biology.
possibly.
Well, it's only 5 centimeters across or so. It's smaller than the 10 centimeter laser spot, so it's not big.
It looks like a nut of some sort.
It does. You know, there's going to be some really ticked off squirrel. I can't remember where they buried that. So we're beginning our move to the northwest now. We've done our quick shuffle across the saddle, and it's time to get the adrenaline racing.
Chris, the next time you see one of those holothurians that looks as though it's got a knife sticking in its back, can we have a close look at it, please?
Certainly, we might. Will do. I'll keep an eye out for those, Paul.
I thought it was just something beside it, but I've
100
seen
meters,
two now that
330
look very, very
degrees,
similar.
2 knots.
I'm just wondering if it's Psychoputes.
Okay. Thanks, pilot. Nav, can I just check? We're heading 330. What's the distance?
Slowly bring my head around to 330.
Nav, watch lead.
Sorry, there we go.
Oh, thank you.
330. Overall, it's going to be about 400 meters. I just put in 100 meters to start with.
Very good. I think the last one we probably don't want to go quite as far as you indicated there, because we want the option to be able to go straight uphill to the top of the A03 marker if it's interesting there. A little bit further. There you go. So that's probably 350. Very good.
Video, could you bring out the names for the biddies you sent me? Heather?
So we're starting our move on a heading of 330. We have a vehicle at a water depth of 3495 meters. So we're basically going to be hugging the 3500 meter contour. Altogether, this move is going to take us about 350 meters to the northwest, at which point we'll be directly downslope from the top of the next volcanic ridge. It was at exactly the same location on the previous hill that we actually found our freshest basalts, both as pillow lavas and also a decent number of, it was a small minority, but maybe 10% of what we were looking at were also sheet flows. We're hoping for the pattern to repeat here at the next hill, which is up shallower along the ridge. And if that's what we see, then we may actually drive up to the summit from there. But just to start with, we're going to be going the first 100 meters, get the ship moving, and make sure everything proceeds the way we're predicting it will. Because the nature of exploration is things aren't always what you expect. Otherwise, that really would be boring. There's a pretty little something. Shrimp in the headlights. Here we are coming up on another piece of woodfall. Nav, if we could drop another marker here, please.
I believe this will be 116. I can't hear you, Roman. What's slower time? I think you have some time.
Nav, I agree, MCR 116. And if we could get a zoom on, maybe zoom on this end where the little white creatures are on the end of the wood, please. As we're looking at this, we're at a depth of 3492 meters. And we're on a heading of 051 degrees.
You got 30 seconds. Just push yourself. Okay.
I'm afraid this will have to be quick, guys. We're going to be moving on again very quickly. Ship and Cirrus are already moving.
Right.
And that's a squat lobster hanging on the other side of the wood. All kinds of interesting things make a living there.
Yeah, could you do that?
Paul, do you recognise anything in particular there?
I'm slowly becoming over you.
In particular,
No.
What's that pink thing hanging on the right side?
It's, I don't know, it's pink, it's tubular, and it's gelatinous.
Should start making the shots, the exit shots.
It's got little polyps down the bottom end of it.
Well, can you zoom in? You come out from here well too.
I
Okay.
think it might be a sea squirt.
Okay,
You're pretty much under.
we're on our way, I think. Time to move on. It's interesting, we seem to have seen a lot more woodfall today, unless I'm imagining it, than we've seen elsewhere.
It's more wood than we've seen in the entire expedition combined.
Right. And we're further from Grand Cayman. I mean, you think where we were is only 60 miles from Grand Cayman, and we've come 30 miles further south, so I'm not sure where the nearest land is in other directions from here after that. So, heading back on with the program. Sirius is heading on a bearing of 330 degrees. Little Herc is swimming out to either side to see what it can see at a depth of 3489 meters. And we are continuing over what is currently 100% sediment cover, thick biogenic carbonate, very smooth topography, and we're using that to our advantage to be able to look out for any targets in the sonar. When you have a nice flat surface like this, it means when you do see something interesting, it stands out really nice and bright, and we can find it very easily. That's exactly how we came across the rocks we encountered last time around. Nav, if we have everything up and moving, is there an option to increase the speed to 0.3 knots?
I imagine so, but let's converse real quick.
Thank you.
Pilots in bay, are you guys comfortable with going 0.3? I am. I am. Is it go? You want to weigh in? I don't see anything from 3 knots out? 0.3? Good enough.
Yes.
0.3 knots, please.
Okay, we only have 22 meters.
Thanks,
left
Nav, and
to
we'll
move.
do the
You can
same
go
as
ahead and add
before.
another 100.
If we see the
and it was what?
anything coming up on the sonar, that's when we can actually just stop the ship and actually take a look.
Affirmative.
Thank you.
Okay.
So we're
Sorry, Watson, I was talking to Fred. What did you say?
we'll do the same as we did at the last site. We'll do the 0.3 knots, and then as soon as we see anything in the sonar, we can stop the ship and let everything settle up to take a detailed look. Thank you. So for those of you listening at home, what we've done is just had a quick conversation with the ROV team. We don't see anything on the sonar just yet. We know we have a few hundred meters to run, so we're just increasing the speed to 0.3 knots, which is pretty much what we were doing on the previous survey. And we know that then if we keep an eye out on the sonar, when we see the rocks coming up, we can stop the ship, settle out, and that's how we can cover the ground faster today to get as far as we can within the time available. Because the real truth is that even with 7 minutes to go, it's going to be Paul Tyler that finds the lava flows flooding down the hillside after I've handed over the seat. Oh, he's here already. He doesn't trust me. Okay, well, since Paul is here and he's dressed up nice and warm, ready for the afternoon shift, I will hand over now and leave you alone with your mud and your thoughts. And I hope you all enjoyed the sheet flow this morning, and hopefully we'll find something at least as cool as that again this afternoon. Thanks very much, and Paul will be taking over.
Thanks, Chris. We can assume that you will be in the background making comments, though? Rocks on the sonar.
Go ahead.
Let's go 0.1 knots, please.
0.1. Okay. Go ahead.
Let's go ahead and pause here.
Roger that. Coming all stop.
Gotcha. As you can see here, Bobby and Mike particularly, you can see a very steep slope here that looks like a lithified sediment at the top. And I guess the talus slope is just crumbling sediment underneath.
Yeah, now you're about. Let's go 5 meters. Right? Too close.
Sorry, Paul. We lost communication there for a little while. Can you tell us what the orientation of that scarp is, by any chance?
The orientation,
Yeah, because I'm telling you that.
not at the moment.
Can we get the pilot to spin and look back at it?
They're just getting themselves set up at the moment, Chris.
Thank you.
Can we drop a
Okay,
marker
Nav,
here,
what's
please?
our orientation, please?
So right now you're slightly behind me. Yeah, well, I'm still swinging. You could have a kick move.
Yeah, we can hear you, Harrison.
315.
Did you hear us?
Can someone tell me the orientation of the ROV, which way it's facing? 135, heading for this.
So now you're.
If we can get the heading now while we're facing straight into it, Paul, that'd be great.
Yeah. Nav, what's the heading exactly now, please? We just topped target. It was 100 is the heading, and we just dropped MCR 117.
Thank you.
Now, could you push me a little bit this? Okay, so
There's a lot of discussion going on with the pilots at the moment about orientation here and making sure that the ship and the Sirius are in the right positions.
okay, so now I'm pointed at you. Alright.
I think we just. I think we need a quick look at it because it's really rock we're looking for rather than lithified sediments. I think. A quick scan,
Yeah,
please,
let's
and then
keep
move on to
going.
look at some
But
marine, and
this
then keep
is,
going.
let's pan out.
Do we have the lasers on, Paul, so we can get a scale of the thickness of those layers?
Lasers are on.
They're very tiny in the center of the image right now, Chris,
Yeah.
so the layers are on the order of about half a meter thick each.
Oh, okay. So, wow, quite thick.
That's good. This is quite a little cliff to our right. I don't think it's that high. Look, to me, I would guess a meter or so.
Right, but a meter of displacement is potentially significant.
So I'm slowly tracking northwest.
Yes, we're moving off to the northwest now. Moving off this almost talus slope. I don't know what we're going to find as we go looking up into the top left-hand corner of the screen. You can see other material coming into sight. Yeah, the pilots think this is a landslide just here. You can still, in the top part of the screen, you can still see what looks to me like lithified sediment. And at the bottom, you've got a sort of a talus slope. I don't know if you call it a talus slope when it's fine sediment. But I always think of Wasswater in the Lake District when I think of a talus slope. But it's very steep, whatever it is.
Do you think they can get Sirius in closer to light this? That might be a question for Dave sitting to your left.
The chief scientist is asking if it's possible to move Sirius in to light this up more.
A little bit. Yeah, I'll do. I don't want to push too much forward.
Can you see it in Sirius now, Chris?
Yeah, that's really nice, thank you.
You're doing a good job here.
I think that gives a nice shot just now of just how big the scarp is compared to the size of Little Herc.
And then slowly we'll work to the northern bearing.
And just looking back up the way we've come, you can see it is quite a significant little cliff just there. That's very nice. If you look in Sirius, folks, you can see the ROV moving along. Yeah, we are moving on, Bobby. They're just getting Sirius in position.
Thank you.
If you look at the high pack, we're going up the western side of that ridge.
So I'm
Okay, we're moving away from the wall now, and we're heading off towards the northwest. The ROV, for some reason they're not quite sure, keeps getting pulled into the wall. I guess there must be a current of some sort down there. But it doesn't seem to be much living on this particular spot.
If it's an upflow, you might just check the temperature on the ROV, make sure it's still 4.25.
Hang on, Chris, we've lost the base map for the nav at the moment, so I'll wait till that's back and then I'll ask the nav. Do you have the temperature, Dave? 4.24. 4.24, Chris.
Thanks, Paul. Okay, so that's still normal.
Okay, so, Chris, do you have a good handle on it? You may not have the ability to. I'm just saying, do you have a good handle?
Looks like rock's dead ahead, and the maybe not.
So, let me switch to hard pack. So
Yeah, I think that's just the slope in the sonar, Bobby.
the other window.
Afternoon dreaming.
The other monitor, and then there's survey, and then survey.
Does runny lava show up in sonar?
Does what show up in sonar?
Runny molten lava.
Yeah, there's a
That's
hissing
a really
noise.
good question.
This edge looks. I wonder if we should be a bit deeper.
No, Paul, this is fine. Let's just keep going because we're
Okay, that's
moving
actually.
along this
I'll
sort of
pass that on to the
lump.
pilots. The guys on shore love this, guys. This is fantastic.
And some of the sediment is somewhat darker, and then it gets lighter at the top.
Just like in a box core.
So piloting now point at 60 right now. Yeah, still moving a little bit. I should be.
Kind of a lot of sediment, actually.
I'm actually surprised how much sediment having gone down the East Pacific Rise, I know it's spreading much faster, but the sediment drape quite a long way out is very, very thin. And here, what appears to be the spreading centre, we've got lithified sediments.
Yeah, maybe this is spreading even slower than we think it is.
Could it be spreading faster and further north, or spreading farther north, and hardly spreading at all here?
Hard to know. Yeah, if we look in the Sirius image here, we can just see this sort of wall of sediment continues on with very sort of angular.
The heading is 30 at the
bits
moment.
jutting out.
Heading is 30. Look, so we're coming out of here back onto biogenic sediments. I think I've quite missed them in the last half hour. Only joking. Elevated view there.
We should note when we run out of this scarp a waypoint or a marker as well, just so we can get a general idea of the length of this scarp.
I'll ask Nav for that.
but not till we end the scarp.
Gotcha. It seems quite extensive to me. Would you know? No, did you and Mike predict this?
Absolutely not. We had no idea this was here.
It looks just like an outcrop to me. That you see on land.
This is continuous for many tens of meters along strike, so it's a fairly large feature. It's just a low amplitude feature that we can't resolve in the bathy.
Go ahead.
100 meters, 330 degrees, 0.2 knots, please.
100
just starting
meters,
to move off again.
330 degrees, 0.2 knots.
Affirmative.
Starting now.
As you can see, the ship is over the bank, and we're running along just below the lip of the bank by the looks of it.
So in general, what geology people want to see is they want to get the stratigraphy, the profile. They're particularly interested in borders and layers and arrangement of layers. Yeah, I wasn't really sure what I was looking for at first.
This is great, guys. You're doing a really good job here. They're loving it.
This is fine. We can continue to noodle right along this scarp as long as it continues, and then drop a marker. And this speed is fine. We don't need to look in unless something exceptional sort of pops out at us.
Okay, I got that.
So in this sort of setting, what do we think that the average sort of deposition rate of these kinds of sediments might be?
Is that a question for me or Chris?
A generic.
Anybody that's willing to answer.
A generic ballpark number for North Atlantic biogenic carbonate accumulation is about a centimetre every 1,000 years. So a metre would be 100,000 years worth of accumulation.
But I always thought of this part of the Caribbean as being more oligotrophic than the main Atlantic. But...
Yep, so that's probably the estimate here is maybe... Yeah, exactly. It's probably an overestimate rather than an underestimate here.
This is quite a bit thicker than a meter, so maybe we have 100 or 200,000 years worth of sedimentary deposit here?
Yeah, and I guess we could also do the thought experiment if we think about how wide the Rift Valley wall is between the two Rift Valley walls and the spreading rate, what the age of the Rift Valley is as a whole.
Part of the problem is we're not really completely sure where the Rift Valley walls are.
True enough. But at 1 centimetre a year spreading rate, as people get their eye in, a 1 kilometre wide Rift Valley, or 1 kilometre's worth of spreading, would be equivalent to about 100,000 years, I believe, and 10 kilometres would be about 1 million years. Or am I out by a factor of 10 there?
No, I think you're right. I'm just amazed how thick this is, and the fact that we're on the slope, but we may actually be on the tilted sort of part of the core complexes that's actually being cut by the volcanics. So this may be quite old sediment that the volcanics have been deposited on, and so that's something we need to look for too.
That's a good point. I mean, yesterday we actually saw sediment. We saw evidence for layers of volcanics on top of sediment.
So this could be old sediment, not sort of ridge axis sediment per se, but on the core complex that's now
I'm
been
still in
split.
training
And
as
then we
well.
have
Yeah, that sounds good, Bobby. I mean, I can imagine that. Well, I mean, it's definitely very lithified. I'm not sure how fast that kind of process would take place otherwise.
except for methane seeps.
Well, just keep glancing over at the Sirius view and keep track of that. And notice the catenary between your floats. That'll tell you how you're doing.
That looks a really risky place to be a sponge.
Is there any way that the volcanic axis we were on before could have stepped off to left or right, and this is a rifted piece that's been left behind that is older?
That was kind of what I was hinting at. And perhaps the volcanic axis has stepped to the right from here. And again, there is a spire down to the left as well.
Okay, a completely different orientation. What about if this is old sediment and then the volcanics have come up underneath it and pushed it up, and the volcanics are uphill to our right?
We're just looking at these grooves here, wondering if these are beginning of cracks. And just at the face there was a piece that looked as though it was about to fall off. And then there's these grooves here. Do you think these are the beginnings of slippage, possibly?
Yeah, they look like long, linear sort of crack features that maybe, you know, the sort of the head wall or the scarp moving into the main lithified sediment to the right in this image. What is the direction of those cracks? So we have, what's the direction, of the Little Herc right now? And back to Chris's comment, yeah, it could easily be that these are old sediments, sort of like a little bit of the
Hang on, Bobby.
core complex that was sedimented that's cut by the volcanic axis to the right. Thanks, Paul.
It went up to 345 when they checked it out.
Thank you.
Okay, guys, if we can continue to follow the cliff, please.
Doing so. Sirius is traveling along the direction of the cliff
I'm with Chris.
at 0.2 knots.
Travelling at 0.2 knots at the moment along this edge of the cliff in a roughly north-northwest direction. Now, that's a philosophical question there, Chris. This lithified sediment to our right, is that rock yet, or is that still sediment?
Well, sedimentary rocks are still sediment in my book.
Yeah, but when you smash them with a hammer, they still break like rocks.
Yeah, but they were never liquid magma, and that doesn't get me excited in the same way.
Oh yeah, but one of the categories of a rock is not what gets Chris German excited, is it?
No, but things we should be looking at and exploring for, I think, should be.
Yeah, I understand that today, yes.
But yeah, no, your point's good that, yeah, this is at that transition from sediment to rock. Clearly, all sedimentary rocks did start off as just soft sediment, like the stuff we've been driving over for the last few days off and on.
Yeah.
going at a fair clip.
And when you can actually sustain big cracks through this, that tells you that's where it's becoming rigid enough that
Yeah.
it's growing up to become a real rock.
Now the question was philosophical as opposed to what we're doing today. Now we are moving along to the edge here because that piece looks as though it's about to fall off. And I guess it'd be interesting to see if we went down the bottom of this slope, whether there's sort of boulders like that lying at the bottom or whether they just fragment.
Go ahead.
Well, that would be the real test of whether they were a real rock or
What's your
not, if they could
what
actually
speed are we
maintain
going?
their
Yeah.
integrity to the bottom of the hill.
Okay,
No, of course,
how much
yeah.
remaining in this move?
42 meters.
But let's not do
Having
that either.
No, I'm trying. No, we're moving along. They just the tether's a bit taut at the moment.
Yeah, if we can just continue along the slope to try and get up to our waypoint marker A03, that would be wonderful.
Yeah, we just discussed about moving the speed up to 0.3, but I think wisely they've said that they might bump into something. So we're going to go along at 0.2 knots still.
Okay. With a little time and temperature, these rocks could turn into a beautiful marble, and then you could, sort of sculpt them into beautiful things like Michelangelo's David.
Achievable lateral motion. So that's something you can put in your trick bag, right? The vehicle doesn't care. It has no clue.
Nav bridge.
Go ahead.
Can you tell me what general direction we're going to be moving?
That sounds like my
for the
skiing.
next, say, 30 minutes to an hour.
We've got another 150 meters or so in this direction, and then we'll probably be moving to the northeast.
Okay, that works. We may be doing a test CTD cast.
Yeah, you should be. We won't. Hold on, give me a second. All the direction of movement should be conducive to a test CTD cast.
That sounds great. I'll let you know when we're getting ready to put it in the water.
Thanks.
Looks like now the ridge is heading off a little bit more westerly here. Okay. Come left. Here's what I want to do is I want you to align the vehicle so you're parallel with the sonar. And that's how we determine the stride. Yeah.
Paul, earlier on you were noting that there's very little in terms of living organisms here, and do you have any idea why this might be the case?
My instantaneous response would be the deeper you go in the ocean, the less biomass there is anyway. And there's a lot of evidence both in megafauna, macrofauna and myofauna that the biomass decreases with depth, more or less exponentially. The fish are slightly different. They do decrease in total biomass with depth, but what you tend to get with depth is bigger fish. So the biomass is concentrated, the smaller biomass is concentrated in fewer fish. That's what it's really saying. And that's why we're down at 3,400. I'm not expecting a huge amount just here. Okay.
I just think come up a little bit because it was all tending, 330, 340. Now we're on a section where it's taken off to the north here a little bit.
It appears that this sort of sedimentary wall is going towards the north more now. I think we might be getting roughly or nearer towards the end of it. Not quite sure. Just following it along.
Okay, we'll just keep going.
It's one of those outer space fishes.
Oh, that's good. It does look impressive looking down the cliff there.
Okay, I think we're still okay with ship setting. We'll see if it zags back to the west a little as we advance here.
Okay, we're going over the lip again, and we're going to go down and look at the face again. We're coming up every so often just to get slightly reorientated.
Go ahead, Bridge.
13 meters remaining in the move.
Thank you.
Are we going to continue on this move, or are we going to come to a stop?
As you can see from the nav.
Yeah, we can continue this move. Maybe 140 meters. I mean 120 meters.
An extra 120 meters, same direction.
We continue this particular move.
Yes.
We continue for about another 120 meters.
Bridge,
so we'll see if we follow the ridge all that way.
Are we going to continue an extra
Then
100
we'll
meters
see if we can find some more
at
rock.
0.2 knots?
Yes, that is correct.
Okay. Continuing along.
Yeah. It looks from the sonar as though this might bear round to the west in a minute. Looking at the sonar in maybe 10, 15 meters time. Oh, so acceleration. There seems to be cliff seems to be diminishing here. Nope, still there. Yep, still there. And looking at the sonar, yeah, it seems to go on this little cliff as far as the eye can see, and it's just below this bank that's to our really due north from us. I have to admit, this wasn't the sort of rock or sediment I was expecting to see here. I was expecting to see, solid rock. I'm not sure if it's my impression or the way the ROV is, but I get the feeling the cliff is a little higher here, and it looks as though it's swinging round there. You can see a colour differential, yeah. Chris, I have a question for you. Do we want to go through A3? Okay, I think Chris is most likely reading his book and gone to sleep for the afternoon. It is Saturday afternoon when all's said and done. I know he hasn't been out for a lunchtime pint. Bobby, do we want to go straight through, take the ROV straight through A3?
Carry along this slope for a bit longer.
Okay, we'd like to carry along this slope for a bit longer, please, folks. They're enjoying this.
So the issue is that probably if we go up to A3, we're probably just going to go into the thick sediment and we won't even see a section through it.
No, I agree entirely. I'm happy to follow this contour here while it's still there. Yeah. I think this is going to be a nice little challenge for you solid rock geologists to explain this one away. Boy. I'm not even sure what it is. Can any of the biologists there make out what the organism is? I wonder if it's a polychaete, but it... Oh, this is Tomopteris. Oh, fabulous. This is a planktonic polychaete. And the spines and the what they call the parapodia, the sort of flappy parts that you get of a polychaete in the sediment, are used for swimming. And if we do see it close up, you'll see it has these very long bits that stick out the side that are swimming. The way it was moving, I thought it might be something like that. Very nice. Actually, it's not very often one sees Tomopteris in the alive, because they're nearly always collected in plankton nets. To actually see one swimming, and particularly this close to the seabed, it's interesting. This is a deep sea bed. Yes, you get Tomopteris, you get it around the British Isles just in the plankton, but you get it at all depths, I think. But this is pretty deep. 3,400 meters or so. That's serious. Now that does look like a Stauromedusae. It's a dandelion, was it? Yeah. Okay. Let's keep going, please, guys. Oh yeah, yes we could please. Sorry, Bobby, I would like to just get some video of this Holothurian. One, looks as though this is forming a trail. I just want to see if it is what I think it is. Then we can actually pack up.
Okay, fine with us.
Indeed, I wasn't sure whether it was something beside it, but I know what it is now. Um, when we zoom in, I might be able to tell you better. Oh, this is absolutely wonderful. This is just glorious. This is a sea cucumber called Psychropotes. That's fine, I can still see it. Um, called Psychropotes, and the piece that's sticking out of its back is its what they call its sail, and we don't quite know what it does, and it's thought it might be something to do with storage. But the important feature is that the position of that sail on the back determines which species it is. And there are two main species, Longicorda depressa, which has the sail in the middle of the back, and Longicorda, Psychropotes longicorda, which has the sail at the very rear end. And you find these two, um, within the deep sea at these sort of depths. So very, very nice. Thank you, guys. Uh, the ama- the amazing thing about that particular genus is it can grow up to almost a metre in length, including the sail. No, and I've got a picture of one of our graduate students holding one after we'd collected it with the ROV in the Whittard Canyon, and it is an absolute monster. Okay. Yes, the sonar says we still have the cliff to our left, to our right.
Can someone, maybe navigation, tell us the distance that we've gone from marker 117 to the present location?
Nav, Paul here. Could you tell us how far we've travelled since the last waypoint, which I've got down as 118? No, 117. Still waiting. We've come about 200 metres. Thank you, Nav.
Wow, this is a long scarp.
Chris, there's 30 meters left in the ship move. I think when the ship is there, I will ask them to move up to AO3. Is that okay?
Yep, that sounds good, Paul. They'll probably need to stop the ship and let it all settle out for about 10 minutes because it's such a sharp change in direction.
I understand that.
And then I think one of the things Mike suggested is when we get up to the top of the hill, we think about whether we keep going along the ridge or whether we drop down the other side.
Yeah, look at it again. This cliff is just keeping going.
I know not all of my colleagues here agree with this, but my feeling is that this is old sediment that's been deposited on the now broken up bits of the southeast corner detachment fault system.
Okay.
And then the volcanic rocks may be actually intruding through and deposited on top of this material. But this is my opinion right now only.
Hang on, Bobby. Nav, once the ship's in position, what we'd like to do is go from where we settle and then move directly towards 03.
Nav, bridge.
Yes, go ahead.
We're 20 meters from the end of the move.
Thank you.
Are we going to keep going or are we going to stop?
No, we're going to stop.
Okay.
Yeah, just to follow up on Bobby's comment, I think certainly the thing that seems obvious is this much sediment must be old, and those rocks didn't look consistent with being older than the sediments.
Okay.
So we're going to go 119 meters at 45.
Nav, could we have a marker here, please? And I would make it 118.
Is that the end of the scarp, Paul, or just where we're changing direction?
This is a change of direction now because we're going to we've finished the ship maneuver and we're moving up towards the A3 now. But the scarp seems to continue on quite a long way. That looks like a pen.
Have you actually started a new ship movement, or are you still ending the old one?
They're still ending the old one. They're just sort of getting it organised.
Well, then Sirius probably hasn't finished moving yet. This probably isn't the furthest we're going to go along this direction.
I think we've come up over the top of the... I think this is as far as we're coming along the edge.
Okay, could we get a heading and a depth now then, please?
Could we have a heading and a depth, please?
Yes, heading is 27, depth is 3477.
Heading is 27 degrees, depth is 3477.
Thank you.
The CTD cast.
We don't see many of them, so it's nice.
We're on a very steep hill. So
Okay, stay point one.
Yes.
Okay.
Well, I won't go on about it now, guys. Anything you want to know about asteroid reproduction, I can actually spend an even boring you to tears. Yeah.
Bridge RV now?
Go ahead.
What's the status of this move?
We have 94 meters remaining.
Thanks.
Oh, that was 8 or 10 centimetres across, wasn't it?
So the CTD basically.
Oh, something's moved away from there recently. Oh. Oh, okay. Yeah. He likes to have a clean rov. The end of the dive. Just to change the subject slightly, Chris, we seem to have a more varied sedimentary fauna at 3,400 meters than we had at 2,300 meters.
Yeah, I've noticed that as well, Paul. If we can't do that as a way to get to steep contours, then what I would suggest is we actually go where we are now. Oh, sorry, the high back's just gone. There's a little green nose sticking out to the east downhill from where we are.
Yeah.
If we could drive over there into the water column like we did last night, drop down and then turn around and come sort
up.
of west back up the hill that side.
Yep, got that one. Call it 5C. We've got a new point 5C, Chris, at the top of that steep slope where that contour is. It forms a circle.
Good.
Just to the southeast of 3400 on your map of this morning.
Yep, that looks great. And can we get there in the hour we have remaining?
He's just calculating.
Thank you.
So, science, I could go faster. This might have lag, but I'm not sure if I want to go 0.3.
And perhaps give the navigator the other option, Paul, of dropping over the other side and see which one of those two he thinks would give us more time looking at rocks.
Chris, hang on.
Very good.
Sorry, Nav?
Yeah, so for it turns out for 0.4, I can probably go 0.3. If you see my arrow up there, but I don't want to go 0.3 up the side of the point.
No, I understand that completely. I was suggesting 0.3 to A4 and then go down to 0.2 to go up the cliff.
Okay, so
Or 0.1 even.
let's keep conservative and let's calculate 0.1.
They're still calculating, Chris.
Standing by.
That's a lovely sea star, though. Oh, yeah. Oh, look at the little spines at the end of the arms, sticking up nicely. And the round things that you see in the centre there, they're called paxilli. And it's the paxilli on the arms like that. They give name to the rise to the family name, which is Paxillosa. I tell you, I have so much useless information.
How did you learn all this stuff, Paul?
Basically, just 40 years of sitting and listening. And there are certain things I can't even remember people's names nowadays. You know, it's an absolute nightmare trying to remember names. Yeah.
Yeah, so I just calculated. So we have about 200 minutes left in the bottom point. Stand by. That's the wrong number.
Yeah, not 200 minutes.
We don't have 200 minutes. So we have 70 minutes. So we can get to A4. That's a 50-minute move. And we have 73 minutes. So that, and then from A4 to A5C, the new waypoint,
Yeah.
is 176 minutes because it's at the low.
Okay. Let me talk to Chris.
Okay. We're not quite at A3.
From that point where it says 1936-56 to go to A4.
Okay, you want just want to stop.
Yeah.
Understood.
It's to, basically it's to go up the slope.
Okay, so you want to explore the slope.
So
go if we can go down to what is now 3B fairly quickly and go up the slope slowly to A4.
and I think they can, if you tell them they can drive out in the water pool to get to A3B, there's no need to keep the bottom in sight trying to go downhill. We'll just get there as quick as we can so we can turn around and then come back up observing on the way back up to 04.
And the chief scientist says if it helps, we can take the ROV through the water column. We don't have to be in touch with the seabed.
Okay, so I'm going to try to call this 3D on keyboards.
That's fantastic video, whoever's taken the video. That's great video. To confirm, we want to go from 03 to 3B, and we're happy to go through the water column. The chief scientist would like to do that quickly, and then we want to go to the seabed at 3B and proceed upslope to A04. I'm not sure if all of you on the beach got all that, but what we're doing, we're going from station A03 to a slightly east-northeast to a spur, and we're calling it station 03B. We're going through the water to get there, and then going upslope to station A04, and seeing what we see on that slope going up. Hope you're happy with that.
That sounds great, Paul. Thanks very much.
Okay, no, Chris's plan. Oh, there's some more grooves there. That's about the first groove we've seen today. Maybe it's not sperm whales. Ah. Thank you very much. Rhode Island, if you look carefully, we can see sediment, and there's some rocks there as well.
Those rocks are pillows.
They're your pillows, are they?
Sure looked like it.
Yeah, we're going to have to continue out to the site, and we'll have to come back. Yeah. Okay, guys, the ship is in position, and the ROV and Sirius are catching it up now. It'll be a few more minutes yet.
The sonar is white. It's so hard of a reflector.
Yeah, at the moment the ROV is facing into the I guess it's facing west more or less, but it's going down backwards. So, yeah, that's right. Yeah. So it's encouraging for when we get there, coming back up. Hope we'll have a good solid wall to go and have a look at.
Hi Paul, this is Chris here.
Hi Chris, welcome back.
Thank you. Is the ship still moving or has it stopped?
The ship stopped. We've just got a few more minutes. We're getting a nice solid reflector if you look at the sonar. At the moment the ROV is facing west, but it's still going, it's sinking to the position.
Right, so we're just settling out.
We're just settling out, yeah.
Very good. And
we've seen some rocks already.
Oh, cool.
But I'm afraid it was literally a glimpse rather than a good look.
No, but it means they're there. That's good.
Yeah.
Mike's plan is working.
And they had that pillow basalt look to them.
Very good. Were they orange or blue?
Say again, Chris?
Were the pillows glowing orange or were they the bluey black colour we used to?
Black and blue. Okay, folks, looks like we're back at the seabed.
We're here with you. Where did the big wall of basalt go?
We're just getting settled, then we're going to be heading off towards 04.
330, right? Let me just double check and see. Chris, let's come to the left. Get lined up for 330.
Nav, can we have a waypoint here, please? 120. Okay, Nav, thank you very much. Oh, nice sponge. We used to get these sort of sponges in our trawl samples, and they're an absolute nightmare because the slivers of silica that make up the stalk go through rubber gloves, anything. Absolutely goes straight into your hand. Really, really nasty if you're trying to sort them. That's a great picture. I think it might be a little snail. A corn cob, yeah. Chris, it's interesting looking at that sediment because when we put the ISIS down on canyon sediments, essentially the lights go out. Yet here the sediment is not easily disturbed and settles out very quickly, suggesting it really is quite coarse.
Either that or it's cohesive. Somehow it's got some, something that binds it together. But one or the other, you're right.
Yeah. Dave's trying to convince me he's delicate like a ballerina. Yeah. Nice sponge.
Well, ISIS is a fair bit bigger and heavier, I guess.
Yeah, but it was also, it's very fine sediments down at 4,000 meters.
So does Dave see anything coming up, or can he kind of recall where we actually did see the rocks?
Bobby, we're trying to work our way up at the moment. We're waiting for things to catch up. We're on our way again now. We're getting onto the steeper bits now. And we should start maybe getting better reflectors in a minute. Bobby, they're suggesting you look at the HiPAC screen and look at the relationship of the ROV to the ship, and you see where we are.
Okay, thank you.
It's really interesting. There's actually more animals on the sediment at 3,400 meters than there was at 2,300 meters. No, I would not have predicted that. And a greater diversity, it seems to me.
there's more, but I can do that. Yeah. Alright, go ahead, Ron. Oh, isn't that great?
Isn't that fabulous? What is it? I think it might be an isopod. I'm not sure. But it'd make a great kid's toy. Beautiful sponge. Champagne glass sponge. Ah, they're amphipods. Oh, brilliant. That's super.
Kind of look like mosquitoes.
That's very nice. Look at that lovely colour. The black bit is their gut. That runs sort of down the backbone part. Nice red. Why should they have a red head at 3,500 meters? No one can see it.
That redness, Paul, is actually their fingers, their arms when they're grabbing.
Thank you very much. Okay.
You just lift off and push ahead. Just like that. Extend this lead another 100 meters. 10 decimals. We're at 200 meters. Stay off the bottom. Yeah, that's correct. I don't like that. They do run away from you, don't they?
Well, you're most likely the brightest thing they've ever seen.
Crest is going to be a drop in here now that I turn. Okay. Alright, well, you still are close to the gray box. A little bit of glare. Good. Well, if I were to guess, I'm going to say this same setting for tank lit.
Oh, yeah. This looks like the other side of what we saw earlier on, folks.
These are low. Right.
Okay, keep going up, I think.
So,
Yeah. Yep. Yep.
so I don't,
Can we have a depth here, please, Paul?
I don't want to go on the
And can we put down a marker, please?
so he gets on
Okay.
the side. Yeah, I might actually turn to look at you.
Nav, could we have a marker here, please? 121.
Just push along. Just push along the edge there, nice and slow. Sure. I'm going to turn my head back. Okay. And
Uh,
nicely moving the crest.
and where's the depth?
Okay.
Oh, 2525.
Feather there. Yeah.
Chris and Robbie, Bobby, we're going to continue going up. because the solid rock we saw on the way down was more shallow than this. So we're going to
Very good.
continue straight up without stopping.
That's great, and maybe we'll actually see it being deposited on top of these carbonates.
Well, that would be cool, wouldn't it? I don't know what it would mean, but it'd be really nice.
It would be wonderful.
Oh, I love enthusiasm. I really do. So,
Pretty far in front of me. If you wait for me to catch up, you can work this side and then walk. Not right now. Turn the baseline. Only one thruster.
Could we have the lasers on, please?
can we have the lasers on, please? Oh. Yeah. Yeah. Okay. Yep. Are we just positioning at the moment?
Yes.
Yeah. Thank you.
Because you'll have the most amount of free tether if you work in the bottom right quadrant of the TV's. Okay, okay. Yeah, I'll wait up for you then. Yes. I'm moving sideways through the water right now. No, my image, I'm moving this way. Yeah. Yeah. No, this way. Yep. I think we're moving west. We're still moving west. So you're doing this. Like, yeah. I'm going to put you on top of the... So this ship move will put you to the top of the satellite. You should see a clip sometime. Just kind of waiting for you, Jeff. Yeah, now remember, I'm moving. I think I'm moving
Okay, Bobby and Chris, please listen carefully here. Dave is convinced that we're going to go up on a saddle here, and what he's proposing and is actually going to do is move south, and where we cross the white contour line further south, we're going to look there because that's where we saw the exposed rocks. So we're going to head south now. I hope you approve of that.
No, it sounds very good, Paul. Thank you.
Okay, mate. Don't thank me, thank
Anywhere we
Dave.
can find rocks is where we want to be.
Yep, that's what we're going to do.
Okay, Vince. Lay us a course for that target we dropped in parallels. Okay. Trying to find the target. It's due south of the boat almost. Yeah, quite a bit south. No, I'm lost. Zoom in on the ship, please. Okay. Position primary south. So our outbound track crosses the white contour? Yeah. Just kind of lead away from it. So you just want to go wing. Deep front. Deep front. Can you see it go along with right there? Yeah, that's where you dropped the target. Oh, excellent. I was looking at 110. Sorry about that.
Yes, that's correct, Chris.
Bridge, Harvey Knight. Snap zoom on it again.
Okay, cardboard box. It is an enormous amount of rubbish. Where is this?
Go ahead, Dave. Yep.
Psychopotes again.
Other side. You want to pull all that front of it? Roger that. You have time. You have a good position and then catching up to it. You start to zoom. Get settled there. Is that going to be too far away? How about right there?
That is fantastic.
No sediment in the water right now. Try to turn as you say so.
That's beautiful, guys. That is absolutely. That's the back end, by the way. It's not the front end. The front end's the far end. It looks like one of those 1930s racing cars.
Is it a particular variety of all there?
Absolutely wonderful colour.
Variety of dolphin.
Wonderful colour.
Tilt on the left a little, so just have to use the best one. Hall of Fame voters. Graham Hill, Graham for them?
Oh, you know Graham Hill. Oh, yeah. Boy. No, that's just great. That'll make a great still.
Probably looking good.
We have to stop, guys. No, we're not wasting time here. We have to stop.
Yeah, Paul, you can tell Sirius is still moving at point 2. They are so darn good.
Yep, Sirius is still moving. That's what matters as well.
Whenever you have what you need, I'm going to look that. So just push straight ahead. That's about be right back to Noah's spin.
Ah, I see rocks. Yeah. Yeah.
Yahoo!
I see rocks.
Rock! Rock!
Rocks.
We'll get there in a minute or so.
Woo! Woo! Thanks, Dave.
Roger that. Robotide?
Guys, we've been extended for another 40 minutes. This is really good. So we'll sit here and we will get everything we can at this near this spot. Okay?
Did you say 40 or 14?
40.
Let me interject there. This is Chris. We'd like to say thanks today. We say thanks to everybody up to and including the CO for this permission, and it's for a maximum of 40 minutes, but you're biting into other people's times, so the faster you can do what you need to do here, the better.
Yes, let's start the ship.
Ready? Go.
I'm looking.
I'm just staying off it so I don't get pulled into anything. But you're still how far away? Not so far.
Everyone, get your eyes peeled
I'll show 'em,
for heat flows
when we get a
and
good spot
basalt
here.
if you can. If not, let us know what you think you see.
I see pillows to the right of the screen.
Science, do you want me to drop a
Okay, good job, Paul.
Waypoint, yes, please. 122.
Agreed. 1, 2, 2.
And our depth right now?
And depth 3494.
Roger that. Starting to come over me, Joe? No, I'm just trying to look along the edge of the peak here. Got a big one back there. Yeah. Okay. Turn to your right. Come to the center of my screen.
Can we work our way slowly up this outcrop at all?
They're just getting settled at the moment.
Come into the center of the Sirius picture.
How about that?
Good job, Paul. Excellent. That is a pillow.
That is a real pillow. Okay,
Do we have our lasers on at the moment?
lasers on, please, guys. I thought they were. Yep. Now, Bobby, I would suggest moving to the right and then upwards along here, but steadily to the right. No, sorry, to the left.
Okay.
To the left.
Yeah, left,
Yeah.
I think.
Yeah.
Right.
Yeah,
And
steady to
it
the
could
left.
be there's a little bit of sheet flow below that big giant
Yeah.
pillow down there.
Pilot, if we can look down to the bottom left. Bottom left. Down now, please.
Below the pillow that's in the center left
Yeah.
bottom.
Yep. That looks like, yeah, just coming into sight. That sheet. And that, no, it looks pillow to the left, the bottom left now. I think you're seeing outer crust there, aren't you, of a pillar lava, Chris, rather than sheet?
Yeah, you're right. That's correct.
Yeah. Okay, guys, if we can work our way along this face nice and slowly, please. Don't mind if you go up and down a little bit. That'll be just great. To the left, yes, please.
Definitely. Again, like the other outcrop we saw earlier today, I mean, these are pillows, and they look like they've sort of moved down slope to this position. And so these are in situ pillows. They're not angular rubble or fragments or anything.
That looks like a big pillow. Sorry to interrupt.
Mound.
Can we zoom in on that stuff just to the left of the lasers there? It looks like it's multiple
zoom in,
layers.
please, onto the pillow there? To just
directly
by
above the lasers.
Directly above the lasers.
Like multiple flat layers there, just above the lasers.
Looks like a series of little steps. That's a series of layers to me.
I'm going to come down and look at a good feed, Paul.
Actually, can you see the piece? Can we just go slightly right there, please? Bobby, can you see the piece just coming to view on the right there? That looks platy to me. Are those upended?
Right. Yeah.
You see that piece?
Exactly.
Yeah.
We can. It could be a tiny little bit of a sheet flow that's interlayered in the pillows, and we're getting funny little angles here.
Okay, if we could zoom out, please. Okay.
And keep moving along the slope.
Yeah. Please keep moving along. I think we might be coming towards the end of it. Chris? Where's he gone?
Yeah. Okay, Bobby. Paul has given me the hot seat back for the last 10 minutes. He's very generous. Is your thought we want to go up slope from here rather than along, or do you want to go along and look at variability?
I guess I can't exactly tell from the sonar if we go up what we're going to see, but I'd like to see, I mean, these things are coming down slope, so I'd like to go up to try and find where they
I
came
tell you what,
from.
have a look at the Sirius view right now. We've got plenty to look at to the left for probably another 10 meters. So how about we go another 5 meters to the left and see what we see? See any variability along here? And then we can go up slope when that's run out.
Okay, yeah, it looks like, in fact, there's just sediment on top of this, and so it may be a very narrow band of stuff that's exposed.
Yep, it may not take us long, but at least we get to see it thoroughly before we go. How about that?
Cool.
And in fact, there's the series probably suggests this may be the only piece of rock there is here, but I think we've seen, certainly we can see pillow lavas. I'd like to believe we've seen at least some evidence for sheet flows as well, that flat layers we saw earlier. So it's all kind of consistent that this volcanic, or this topographic high, this ridge, then is consistent with what we saw at the previous ridge as well. But this is all very much in situ, I think. Don't you agree, Bobby? These aren't loose boulders. This is an accumulation of lava.
Yeah, that's correct. This is definitely in original seafloor, and these things came out here.
So in fact, we've made the main achievement of finding this set of rocks here, that we can show that this is a coherent lava flow that is uphill and up sequence from the sediments we were looking at further down with that exposed scarp.
I'm not sure about that because, again, those sediments could be banked up against these deposits.
Oh, okay, you think, okay. Yes, please.
I
Yeah,
mean,
that wrinkle. Hang on a minute, Bobby. Yeah, pilot. Just above the lasers, that surface there, that looks like a very diagnostic swirl of flow surface.
wow,
Uh,
that's beautiful.
okay, that's my image of the day. If I worked on these specific MRIs more or listened to Dan Venari more often, I'd actually know the name for that kind of flow. It's
Called
like
ropey or pahoehoe lava.
pahoehoe. There we go. Ropey lava flows, guys. And I have to go and
And
talk about the future of Pacific Ocean exploration next month. So I'll actually get to see it in Hawaii without so much water over it. Go ahead, Bobby. Sorry.
oh, no, it's just called pahoehoe lava. Is the sort of clinkery stuff that's very not as smooth and beautiful as this. So this is pahoehoe lava, and that's beautiful. It's got to be fairly fresh in order to have that structure preserved.
Right, to actually preserve that texture.
Yeah, I mean, I'm not going to say
Yeah.
how
No,
recent, but
relatively.
not too old.
Amongst geologists, we understand what recent means. Thank you, pilot. That was really quite splendid, including the fact that you spotted it while I was talking about something else.
And that should definitely be a highlight, I think, of the day.
Quite so.
Chris is really settled in here, so you've got all the time you want. Okay.
Okay, Bobby. Which way should we go now? We've got everything beautifully settled up, and guys, we're basically, I think one of the things to be looking out for is anything with a flat top. We've seen a lot of pillow basalts, but when we find the flatter surfaces, if we can find compelling evidence for sheet flow, that tells us something about faster rates of eruption. Just to the right of your lasers right now, just disappearing off the field of view. If we can pan right, please. Go right, 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 right. Keep going right. And then I think further right and maybe back out a little. Yeah, I think I saw something above that flat rock. That's the thing that's right above you now. I think it was disappearing out of the top of the... There we go. You can see an overhang on the top right. Was that the one we just looked at before already? Okay, keep coming up with your lasers, and it's almost due right of you now. Spin right there. Was that the one we just looked at? Okay. Well, that's nice because then actually we've got the underside of that. You can see how that's a flat ledge. And in fact, there's some of that texture again on the right under your lasers there as well. So there's that piece on the right there, and just above you the piece at the very top of your screen right now has the same thing on it. We can come back around when you get settled up. It was yes. There's a horizontal one with a big shadow under it. Top right of your screen right now. So on the right hand side of your screen at the equator. Oh, there we go. Okay, so if you hold there a moment, there's both the rock to the right of your lasers and the rock above it both have that swirly texture on it. So maybe we could look at the one on the right first, and then we'll look at the one with the overhang afterwards.
Beautiful, beautiful, beautiful.
That's one. And then if we can just maybe bring the vehicle across and down to see the other piece of rock. And it's just off your screen to the right now, bottom right corner. And I think the other one, there you go, the other one's tilted down so you can, it's beautifully lit. And the sediment's pulling out the markings there. That one just down below your laser on the right, yeah, if you see all the one with all the... That is super. Can we zoom out just a little, get the whole rock in the frame? That is great. And we've got our lasers there for 10 centimeter scale. That's enough to make a geologist very happy. Thank you, guys.
So just
Okay.
to the left of the left laser? Is that a tube, but not the fun
I don't
kind?
know. Yeah, pilot, can we look at that little white thing that's in that picture? Sorry. It's going to be one of these little polychaete worms. Paul, are you near a microphone? Ready to tell us what it is we see when we zoom in here?
But I'm not really sure.
Okay, I think we should be able to, can we zoom in any further, or are we full in? Totally tubular.
Boy, if I was being asked, I would say that was a tube worm.
I know.
You know, no. That's
Why
not going to
not?
happen.
Why not? What is it?
I
It's
would
long,
be.
it's white, it's tubular.
Yeah. So it's the tube of a worm. I think
It's,
is the
there we go.
safest thing I would say.
We can have worm tube, right?
A worm tube's okay.
Very good.
Okay. Do we have time to just move to the left a bit along this slope for a couple more minutes?
Say again, Bobby.
We move to the left along the slope here for a couple more minutes.
Sure. Looks like that's where our guys are off to. Let me just talk with them. So, and a request from the beach is that we could move a little bit further along this slope and see what else we find.
Oh, somebody had beer before we got here.
Yep, let's go a little bit further along the slope, if you don't mind. At least we can check out our colour correction if we know what brand that beer bottle was later. I've known AUV teams do that with Chinese beers in the Indian Ocean before now.
Things are
This looks
looking
like a
more
little
platey
flat.
here.
Yeah, this looks just to the right of the lasers there. Can we look at that? Ah, now Bobby, that looks like a tube coming out of the wall towards us. Yeah, there's sediment draped over it, but I don't know. So that looks like that's an unreasonably flat plate to the right of the lasers there. If we can work our way back to that, please, pilot. But it's not often you see a horizontal surface like that in nature. And the way that works for the guys in the front row is basically a liquid that... Yeah. Sorry.
Would you say that's a drained lava tube?
It could well be. I mean, that horizontal surface, right? The only way you get that in nature is that's a liquid settling out to a constant surface.
Looks like those things you see in Hawaii.
Yeah, it's
Grass skirts, Paul?
amazing. Coconuts and beer.
You know that highlight of the day we just had, Bobby? I think we just displaced it.
Just made it a second highlight.
The cruise, it just keeps giving. It was playing all that primal scream in my stateroom that got me pumped. That's how I knew we were going to get good rocks today. Oh, that is awesome.
That really is amazing. I mean, you barely ever even see that in Hawaii.
I know. I'll be selling postcards. Can we just zoom out a little bit to get the whole thing in view, please? Cool. Now, and I'm going to be completely demanding again. If the camera isn't horizontal already, can we bring the vehicle down and so we can try and look at the underside a little as well? And then if we bring a second ROV in from the right with a bit of pink mood lighting as well. You'll promise me anything now, right?
Chris, that's really peculiar
And
how that's
maybe-
formed.
Say again, Paul.
It's really peculiar how that's formed. That platy piece looks as though it's in the middle of a lava tube.
Exactly. So what Bobby's interpretation is that because we know that the pillows are frozen around the outside and still liquid on the inside, if it then drains back, if the lava flows back into the hillside, you end up with a cavity with there would have been water above that flat surface, the rest of the lava beneath, all inside the outer crust, which is the thick thing that's about 10 centimeters thick that was the chilled margin of the pillow tube. So imagine a tunnel. Imagine you're down in the tube station at midnight with Mike Cheadle, and you're inside the tunnel looking straight ahead there, and there's liquid lava up to the top of that flat surface, and there's seawater above that. And then, that's one of the ways hydrothermal activity can get started. Hot rocks and water. But look at that, a perfect horizontal surface. That is beautiful, guys.
That is beautiful. Wow.
Round of applause for the front row. Kudos, guys. That is amazing work.
And for their perseverance, despite the fact that they thought we were nuts when we said we saw rock.
I know, I mean, this, well, thanks to everybody aboard the ship, right up to from the CO down. But yeah, nobody knew the rocks are going to be this good. So remember, guys, we've seen all this phenomenal lava, the stuff that's hard to see on Hawaii, on an ultra-slow spreading ridge. The kind of place you really shouldn't come and look for volcanic stuff because it's boring. So long as you get consistently lucky, that's all you need to ask for. You know, Bobby, I think we've pushed everybody's limits here. Is there anything else you want to see? Maybe we want to see how far this rock goes before we run out? Oh, hang on, we didn't drop a marker there.
Yeah, we can.
Nav,
Whatever
can
you
we
guys
drop-
are willing to do.
Nav, can we drop a marker there, please? I hope somebody's... and if we could just... I'm really sorry, I didn't get the depth and heading while we were sat there. If we can try and simulate that. Maybe Pilot, if you can just kind of vaguely point yourself back where we were before.
This really looks like big flat sheets up ahead, Chris.
So our depth is 3494 meters, and if we were facing into the hillside, actually if you just spin to your left, Pilot, it would have been around 290 degrees. You know what we're looking at there? That looks like, Paul's right, that looks like all flat stuff in front of us there. And that's pretty much the end of the outcrop, so if we can... Pilot, I think that's as far as we want to go along this face. But there's some flat stuff there. If we could just go and have a look at those flat things down to your right. You see all those big flat plates? Let's go check those out. And I think at that point, we're going to say thank you very much to you all, and we'll bail out. But let's go take a look at them. Nav, this is probably pretty much the same place where we just dropped that marker, correct?
Yeah, because I dropped another marker.
No, that's fine. It'll be the same place. Don't worry. Pilot, there's
Chris,
some
can we look in
tubular
on those
things on top of
tubes?
those. Yeah. Can you see just a... Let's go look at those as well. Now they know we're coming. Actually, they won't be able to see us coming now. Our depth is 3495 meters. We're on a heading of 294 degrees. We're looking at flat plates, the order of a meter across. We have some tubular straggly things, 2 or 3 individuals. They themselves are 20 to 30 centimeters long, sitting on top of the plates. And we are just a long strike to the west from where we went from pillow lavas. So we went from pillow lavas to that drained pillow tube, we believe. And now we seem to be in flat, sheety plates of lava.
Yes, I think those worm tubes are attached to the rock.
Yeah, I think they would have blown away by now otherwise. Well, I think once again, team,
Are the lasers still on? Oh,
they are. Yep, they're on the big plate center bottom.
and so the individual slabs are about 5 to 8 centimeters thick. Is that correct?
I would guess so. Yeah, they yes. Yeah, because the one to the left of the lasers now, that's actually 2 blocks stepped down, so you can't see the full thickness, but they are quite thick units. We're just going to try and have... Sorry, to the right, pilot. Yep. I think at the join of...
These are...
That... Hang on, Bobby. The unit where your lasers are right now, if you keep going right, and then if you go straight down on that block there, they're kind of in the shadow at the moment. We're just trying to look at these worms, Bobby, on the rocks as well.
That's fine, I understand.
Yeah, they're tuberculous polychaetes.
Are they just like regular common or garden bent thick polychaetes, Paul?
Yes, my guess, yeah.
Yep. Should we zoom in anyway, just to have a quick look since we come this far? If we can.
Yes, please.
I guess that's like the stuff we saw at the other ridge earlier this morning, isn't it? Is that good enough for you, Paul?
Well done, thank you.
Yep, okay, thank you, pilot. No, that's fine, it was enough. We were able to characterize what they were. All things. Absolutely. But surely there should have been last orders. Or maybe we just had that. No, thank you very much, guys. I think we've just had a really great end. And our time is up.
Arvin average?
Yes, we're making our approach to get up.
So, those of you listening at home, we are at a depth of 3493 meters.
We're making our approach.
We are sitting on the seafloor over some spectacular sheet flows from the Mid-Cayman Rise. It's an ultra-slow spreading ridge, but I think we just proved the point that on a day when there is an eruption in a place like this, you can get some pretty cool lavas flowing out in many different ways. I want to say thank you to everybody who's been helping us today aboard the ship, and the perseverance paid off, and the extra time certainly paid huge scientific rewards for sticking around a bit longer, so thank you everybody for that. And I know it's the last day we're going to have a full component of our complex core team in the ECC. We're going to be losing Bobby and Jameson tonight, so it's going to be a shame not to have you guys on the line anymore. So thank you everybody, and if you don't mind, what we might do is have a science meeting for our scientists at 5 o'clock local time, just about 12 minutes from now. And we'll do that here aboard the ship at 5 o'clock local time. That'll be 6 o'clock at the ECC. So we won't keep you long, but we'll just wrap up now and start heading up from the seafloor. Thanks very much.
Thanks, Chris, for a great dive. It was very well salvaged there at the end with the beautiful, beautiful volcanic deposit. So we're very happy here.
Good, good. Okay, and Paul sends his thanks and his goodbyes to you, Bobby, and to Jameson, although we'll probably have one last chance on the phone shortly once we get out the control room, and we'll do that from our stateroom instead.